Hey guys, tonight we step in close to the glow that sets your day in motion and your circadian rhythm on a leash. We're going to meet the sun not as a loud ball of fire, but as a patient neighbor, steady, musical, and generous, whose light paints your walls and times the birds outside your window. You'll feel how its heartbeat travels as ripples through its body, how its warmth takes the long road to reach your skin, and how its gravity keeps every planet, moon, and dust mote politely in line. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me where you're watching from and your local time in the comments. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Start with the obvious. That warm patch on your blanket is sunlight that left the sun a little over 8 minutes ago. It was born much earlier, deep in the core where hydrogen is squeezed so hard that separate atoms give up pretending to be separate and fuse into helium. In that trade, a tiny pinch of mass becomes energy the way Einstein promised, which is the polite way of saying the sun continuously turns millions of tons of itself into light and heat every second and somehow never brags about it. The photons that will color your morning don't rush. They spend ages bouncing around inside the star, a long crowd surf to the surface, before sprinting across space in a straight shot to your eye. Sunrise is always slightly old news, and somehow that makes it nicer. If you could turn the glare down and listen instead of look, you'd hear that the sun is not silent. It rings. The surface rises and falls in slow, broad notes the way a drum head shivers after a soft strike. Scientists call it helioseismology, which sounds fancier than the idea really is. Watch the ripples decode the interior. Those ripples tell us about layers you can't see, where heat moves easily, where it stalls, how flows twist and shear beneath the bright skin. I like that. We learn to understand a star by treating it like a musical instrument. From your window, it seems simple, a bright face with a clean edge. Up close, it's a busy neighborhood. Across the surface, darker freckles, sunspots, come and go, cooler than their surroundings because snarled magnetic fields choke off heat. Along the rim, loops of glowing plasma arc up and fall back, handwriting made of fire, anchored to lines of magnetism that run invisibly through the plasma sea. Tiny jets, spicules, shoot and fade in minutes like the star is exhaling through 1,000 thin straws. None of it is for our benefit. It's just what hot, ionized gas does when magnetism says this way. The temperature story is a little weird, and I promise it's worth a quiet blink. The layer we see, the photosphere, sits at about 5,500 degrees Celsius, hot enough to make atoms reconsider their life choices. Above it, the atmosphere blooms into the corona, which soars to 1,000,000 degrees or more. Hotter outside than underneath is not how your stove works, and yet the sun makes it normal. The best explanations involve magnetic waves threading outward and tiny explosions called nanoflares, each one too small to headline, together enough to keep the halo blazing. If that still feels unsatisfying, good. You're in the same club as every physicist who refuses to call a mystery solved when it still winks at us. Every decade or so, the whole magnetic field flips. North becomes south and south becomes north with the chill confidence of a star that never asks your permission. During the busy years, the sun looks more speckled, the loops grow taller, and the bright arcs called prominences appear more often. Sometimes it pops, tossing out a flare or a cloud of charged particles, a coronal mass ejection, that later brushes past Earth. That's when auroras wake up and paint polar skies with curtains of green and violet. It's beautiful, yes, but it's also practical. Our satellites notice, radio gets moody, and electrical grids prefer we keep an eye on space weather like grown-ups. If the sun could write a resume, mass would be right up top. It holds more than 99% of everything in the solar system. Planets, moons, comets, all of us together barely add up to a rounding error next to that bulk. Gravity is just mass being socially organized, so the sun's gravity keeps everyone orbiting calm and obedient. The shape of those orbits isn't a perfect circle, but a tidy ellipse, which means each planet has a nearest point and a farthest, a little fast lane and a little slow lane. That's why our seasons come with a rhythm that feels both precise and forgiving. The sun doesn't micromanage. It simply keeps time and lets geometry do the rest. Strip the sun down to ingredients, and you get a simple recipe, mostly hydrogen, mostly helium. The heavier elements that make up your bones and the iron in your blood were born in older stars and scattered long before this one formed. That means, in the most literal, not trying to be poetic way, that you carry the memory of dead stars around with you while you make your coffee. The sun isn't one of those heavy element factories. It's a next-generation child of the galaxy, a clean-burning engine with enough fuel to run our corner of space for billions of years more. And honestly, a little simplicity is soothing in a universe that loves complexity. Because it's steady, we tend to ignore how weirdly dynamic it is. If you could safely watch during an eclipse, when a moon blocks the glare and the corona blooms, you'd see streamers of light stretching far into space, shapes changing minute by minute as magnetic fields reorganize themselves. The sun looks like a serene circle until you take away the shine. Then you see it thinking in plasma, sketching and erasing with light. People travel to the end of the world to stand under that shadow for a few minutes and watch the sky forget itself. When they cry, they aren't being dramatic. A star just showed them its skeleton. Daily life is a set of small favors from this star. It raises weather by warming some places more than others, nudging air and ocean into motion. It tugs water into clouds and gives it back as rain. It goes softer near sunset, and every photographer you've ever liked will tell you that the golden hour isn't magic, it's geometry. Even your sleep is a negotiation with light, whether you like it or not. Your brain takes sunlight seriously, and when winter asks it to calm down, it sometimes grumbles. That's not moodiness. That's biology listening to a star it's known forever. There's also the long view, which is where the gentlest kind of perspective lives. Right now, the balance is comfortable. Gravity squeezes inward, fusion pushes outward, and the star sits in a stable truce. Far in the future, after most of the core hydrogen is spent, that piece will shift. The sun will swell into a red giant, larger and brighter than you want to think about before bed, and then it will shed its outer layers into space like a glowing scarf. What remains will be a white dwarf, a dense ember the size of Earth cooling slowly for longer than any story will last. That isn't tomorrow's problem. It's a reminder that even stars have chapters, and this one is a calm, long middle. If you've ever wondered why the sky sometimes gets noisy with color, especially near the poles, that's the sun tickling Earth's magnetic field. Charged particles stream outward, meet our planet's shield, and ride it toward the poles, where they bump into atoms in the upper air. Those atoms respond the only way they know how, by glowing. Green from oxygen, blues and purples when nitrogen gets involved. It's a light show powered by the same engine that warms the garden, a reminder that beauty and utility often share a power source. I promise to keep the language clean and the pace slow, so here's the simplest truth I can give you before we step outward. The sun is a reliable neighbor with a surprisingly rich interior life. It hums, it freckles, it flips its magnetic coat every 11 years or so. It glows with a halo hotter than its face. It sends out a wind we'll feel soon. And through all of that, it keeps almost everything we love moving on well-behaved paths, asking nothing more of us than the occasional look up and a little respect. Hold that picture as you breathe. Think of a sphere mostly made of hydrogen and helium, stitched with magnetic lines you can't see, but whose effects you can, ringing with gentle pressure waves, and pouring out light that left moments ago and lands right now on your knuckles. In the next stretch, we won't change speed or mood. We'll just lean into the outward flow, the solar wind, and follow it, the way a feather follows a draft down a hallway to the place where the sun's breath meets the thinness between the stars. The draft of the solar wind is already on your face, a pressure you can't feel, but that quietly tugs at everything with electric patience. It begins where we left our gaze a moment ago, in the sun's bright atmosphere, where heat loosens the grip that binds particles together. The upper layers are so hot and thin that protons and electrons slip their leash and drift outward. Drifting turns into an escape, and the escape becomes a continual outflow. That outflow is the solar wind, a river of charged particles, not a gale that rattles windows, but a steady breath that never stops. Even on a calm day, this wind has moods. Part of it is the slow stream, a few hundred kilometers per second, bleeding from regions crowded with magnetic loops that knot and unknot like headphones in a pocket. Part of it is fast, roughly twice that speed, racing out through darker coronal holes where magnetic field lines open like lanes on an empty highway. When a fast stream catches a slow one, they don't pass politely. They pile into each other, building a moving compression, space weather's version of a cold front, that rolls through the solar system and keeps going. Because the wind is charged, it doesn't simply flow, it stitches space with magnetism. The sun spins, the wind streams, and those field lines are wound into a corkscrew called the Parker spiral, a slow-motion pinwheel that every planet sails through. Imagine holding a garden hose while you turn in place. The farther the water travels, the more the stream curves into a spiral path. That's the geometry the planets inhabit, a magnetic pattern that guides particles, shapes waves, and sets the background rhythm of interplanetary space. Inside this spiral current, Earth carries a shield of its own. Our magnetic field takes the brunt of the wind and pushes it aside, sculpting a teardrop, the magnetosphere, squashed on the daylight side and stretched into a long tail at night. Ahead of that shield sits a bow shock where the supersonic wind slows and diverts. Inside, energy pools and drains the way a lake feeds a river through a narrow outlet. Some particles sneak in through the polar cusps and rain down along magnetic lines, lighting the upper air in those theatrical curtains we call auroras. Most are swept around us in a way, as if the planet were wearing a slick raincoat that never gets wet. Move outward and the wind thins but keeps its personality. Past Mars, it is still supersonic, still charged, still carrying the sun's magnetic handwriting far beyond any orbit you've memorized. If you could paint the boundary where this wind finally surrenders, you wouldn't draw a single line. You'd layer a few gentle transitions. First comes the termination shock, where the wind's speed drops below the local sound speed and the flow heats and bunches. Beyond that lies the heliosheath, a broad, turbulent borderland where the wind slows further and wrestles with the pushback from interstellar space. And then, farther still, there's the heliopause. Not a wall, but the place where the sun's influence yields, where the pressure on our side and the pressure on the galaxy's side come into balance. The bubble itself, the heliosphere, is not a perfect sphere. It swells and leans depending on the sun's magnetic mood and on the interstellar breeze we're sailing through. Some models make it rounded with a long, faint tail. Some sketch it more like a double-lobed croissant, pinched near the middle where magnetic forces funnel the flow. You don't need the exact silhouette to hold the feeling. Our star blows a magnetic cocoon around the family of worlds, and that cocoon filters high-energy cosmic rays, calming the interior. It's a kind of weather shield for planets and atmospheres, and for anyone with a bright idea to ride a rocket. If distance feels abstract, switch to time. 2 spacecraft launched in the late 1970s, small, gold-plated optimists, took decades to coast outward after visiting the giant planets. They listened as the wind slowed, as the particle mix changed, as the magnetic field rotated into a direction more dominated by the space between stars than by the sun. One crossed the heliopause first, the other years later. Their signals are faint whispers now, hours in transit, but they still carry news. The wind is different out there. The background is louder with galactic particles. The star's breath ends in a boundary you can feel with instruments, even if no human hand will ever touch it. Closer to the source, another craft has been choosing bravery in the other direction. It dives toward the sun behind a carbon composite heat shield, grazing the lower corona and tasting the wind before it has fully unwound. Out there, dust schemes the shield, plasma flows curl around instruments, and speed becomes a necessity rather than a brag. Falling deep into a star's gravity well, and then swinging back out on a path set by orbital choreography we've learned to sing in equations. The reward is intimacy, measurements from inside the birthplace of the wind, hints of where the slow stream gathers and how the fast stream slips free, even glimpses of magnetic kinks snapping like over-twisted rubber bands. The heliosphere breathes. During quieter solar years, the wind slackens, the bubble relaxes and shrinks a little, and more of the galaxy's high-energy messengers manage to wander inside. During busy years, the field tangles and snaps, the wind stiffens, and the border pushes outward. None of this is dramatic enough to notice on your commute, but over months and seasons the change is real. If you could see charged particles the way you see dust in a shaft of light, you'd watch their density ebb and flow with the sun cycle, and you'd feel a little proud that your sleep schedule is steadier than a star's. Neutral atoms ignore much of this magnetic ceremony. They slip through the heliopause without caring about field lines, mingle with the wind, and sometimes swap electrons with its ions. When that happens, an energetic neutral atom shoots off on a straight path, indifferent to magnetic curves, and some of those straight flyers reach detectors near Earth. By counting their directions and energies, we make global portraits of the boundary without ever traveling there, like mapping the reef by watching the chips of foam that spray off and drift back. Everything we fling upward has to live in this environment. Spacecraft accumulate charge as they plow through plasma, and engineers give them little ways to bleed it off before it bites a circuit. Sensitive parts hide behind shielding. Antennas are tuned to sing through the wind's hiss. When you hear that a telescope has been switched to a safe mode, you're listening to a team reading the space weather forecast and deciding to wait out the gusts. For people, the stakes are personal. Near Earth, we still sit inside the magnetosphere's umbrella, but wander beyond it and the wind becomes part of daily planning. Radiation is not drama. It's arithmetic. Dose adds up. You build shelter, choose your timing, and respect the weather where there is no air. The wind leaves fingerprints all over the neighborhood. Mars, without a global magnetic field, loses atmosphere molecule by molecule to the breeze. The escape is slow, quiet, and relentless, a story written in isotopes and upper air chemistry. Mercury's not quite atmosphere, a delicate exosphere, gets scoured and replenished in a constant exchange with sunlight, meteoroids, and the wind. Comets grow two tails when they fall inward, a pale dust tail pushed by sunlight and a straighter, bluish ion tail shoot away by the solar wind's electric hand. Even the faint rings of distant planets feel the push, their grains charged and nudged, their edges corrugated by invisible weather. If you could hear it, you'd hear almost nothing. Space doesn't carry sound the way air does, but instruments translate pressure waves into audio, and the wind becomes a low hush with the occasional pop and sigh, like listening to a river through the bank instead of from the water's edge. When a coronal mass ejection passes a spacecraft, the tone deepens and swells, and then relaxes. We're good at assigning moods to numbers. That tendency turns data into a feeling your nervous system understands. The sun exhales, the instruments agree, and somewhere in your chest, your own rhythm answers. Hold the picture of the bubble in your hands for a second. Threads of magnetism traced along a spiral, a wide, warm interior, a skin that is not a wall but a handshake, a long wake fading downstream in the galaxy's thin wind. Dents and folds shift as we pass through clumps and gaps in the local interstellar cloud. The whole structure rides with the sun as it loops around the Milky Way on a journey that takes hundreds of millions of years. You live inside a moving shelter inflated by a star. That is the sort of sentence that sounds like poetry until you realize it's just logistics. Learning this is strangely calming. Pressure balances pressure. Flows meet, mingle, and move on. Boundaries aren't hard borders. They're regions where one influence gives way to another. When the sun is playful, the sky writes it for us in light. When the sun is quiet, the wind hums along and nobody notices. Either way, the vast machine keeps time, and the time it keeps is generous to small creatures who sleep under blankets and set alarms. No dramatic pause needed. We're already riding the current, carried by a breath that left a star and filled a bubble bigger than every orbit you've ever seen on a poster. Keep that current in mind as we drift outward along the spiral, because this wind touches every world, shapes every magnet, and leaves a signature on every rock that crosses its path. The story we're in is stitched with invisible lines, and for the next stretch, those lines will remain our guide, faint and steady, pointing the way. The wind we've been riding slips close to the sun, and the light sharpens. Ahead, a small, dappled sphere crosses that glare like a charcoal bead on a bright string. Mercury waits in that heat, close enough to feel the sun's magnetic mood as a nudge, close enough that noon is not just bright, but overwhelming. There's no real sky here, not in the way you know it. No blue, no soft dome to scatter light. Just a black ceiling with a monstrous sun in it, a disk more than twice as wide as it looks from home. Step onto the regolith, and the horizon looks carved, crisp as a paper edge. With no air to blur distance, every ridge looks nearer than it is, like the world is pretending to be smaller than small. You can feel how quickly the ground soaks up heat. On the day side, the top layer cooks past 400 degrees Celsius. Cross into night, and it drops toward minus 180. No atmosphere means no blanket, no evening softness, just a switch from too much to almost none. If you could stand in the twilight zone and squint toward the sun, near Mercury's closest approach, you'd watch a trick of motion that never gets old. The sun seems to climb, pause, sink a little backward, then climb again. That odd dance comes from Mercury's stretched, speedy orbit and its unusual spin. It rotates 3 times for every 2 orbits, a 3:2 resonance that keeps some longitudes baking under extra-long mornings, while others enjoy the briefest of afternoons. Weather forecast: sunny, then very sunny. Night: extremely night. What passes for air? Here's a ghost. Mercury has an exosphere, not an atmosphere. A handful of atoms and molecules set free by the sun's wind and by tiny meteor hits. Sodium, potassium, oxygen, helium. They pop loose from the surface, bounce a while without bumping into each other, then fly away. Some get scooped into a long, faint tail that streams away from the sun like the whisper of a comet. A sodium glow so delicate you need a clever telescope to catch it from Earth. It's a transit system where every rider buys a one-way ticket and the buses are solar photons. That exosphere changes by the day and the season. The season, here being Mercury's position on its 88-day loop. Close to the sun, more sputtering, more pickup ions, more of everything going missing. Farther out, a little calmer, though calm is relative when your neighbor is a thermonuclear machine. Micrometeoroids, the sand of space, pepper the surface, and each tiny impact sends a spurt of atoms lofting up to join the ghost air ballet. That ballet never thickens into clouds or storms. It's too thin for drama, but it leaves fingerprints you can see if you know what to look for. Glows in sodium light, delicate shifts in ultraviolet, a statistical rumor that tells you how hard the sun is breathing today. Beneath that whisper of air, Mercury is all scar and story. There's the immense ring of the Calorus Basin, nearly a third of the planet across, a bowl blown open by a long-ago impact big enough to make your stomach do a small flip. On the far side, where seismic waves converged, the ground crumpled into a weird terrain that looks like the surface remembered the shock and never quite smoothed out. And then there are the lobate scarps, long, curving cliffs where the crust buckled and slid over itself. Those clues say Mercury shrank as it cooled. The oversized iron core contracted, and the brittle skin gathered into wrinkles. Imagine a grape turning into a raisin, but made of rock and metal and grumbling over billions of years. That core is the headline. Proportionally, it's huge. About 80% of the radius is metal, an iron heart that leaves only a thin jacket of rock. How it got that way is still in play. Maybe early collisions stripped off lighter layers. Maybe the inner solar system was simply mean to silicates this close to the fire. Either way, you can feel the consequence under your boots. Gravity a little stronger than you'd guess for a world this small. A planet that clanks more than it thuds if your imagination grants its soundtrack. That core still moves enough to generate a magnetic field. Weak, about 1% of Earth's, but real. It's oddly offset toward the north, as if the dynamo sits slightly off-center and the solar wind presses the dayside magnetosphere down tight to the surface. Mercury's magnetotail whips and brightens quickly when a gust from the sun hits. Space weather here is not an abstract. It's the daily temperament. If you love clean tests of good ideas, Mercury gave physics one of its favorite victory laps. For centuries, astronomers tracked the planet's orbit and noticed a tiny mismatch between prediction and reality. The ellipse slowly swiveled, and although Newton's gravity accounted for almost all of it, there was a leftover, a few dozen arcseconds per century, that refused to behave. Then Einstein wrote down a new way to think about gravity. Not a force tugging across nothing, but mass bending space and time so that paths curve naturally. Run Mercury through that geometry, and the leftover precession lands exactly where the pencil says it will. A small, hot planet nudged a big idea across the finish line. Walk farther poleward and the light changes. Mercury's tilt is almost zero. The sun schemes the horizon at high latitudes and never quite peers into the deepest polar craters. Those floors live in permanent shadow, flash freezers the size of cities. Radar bright spots told the first part of the story. Spacecraft finished it. Water ice hides in those cold traps beneath a dusting of darker, carbon-rich material, layered like frost and soot. Where did the water come from? Likely from countless impacts by comets and water-bearing asteroids, with a possible trickle of chemical release from the planet itself. Without air to shuffle the heat, that ice can survive in those caves of night for millions of years, a stash of cold on a world of heat. There are stranger textures too. Messenger, the spacecraft that orbited here for years, found hollows, bright, shallow pits with soft rims that look as if someone breathed on the rock, and the volatile parts simply left, collapsing the surface into a honeycomb. They're fresh by planetary standards, which means Mercury is still editing itself. You can almost hear the dry humor. A planet this roasted still finds a way to do something evaporative. The ground chemistry tells you why it looks the way it does. Basalt from old, fluid lavas fill plains around the big basins, streaked with jumbled blocks where walls slumped and crater counts climbed. The regolith is a thin, ongoing compromise between bombardment and time. There are no rivers to braid and erase, no glaciers to sand and carry. Micro-impacts, thermal cracking, and chemical sputtering run the workshop. The result is a landscape that gets older without getting much taller, a slow accumulation of roughness and dust punctuated by the occasional civic leveling event from space. You can stand your mind on a crater rim and iron out how a day feels. Because of that 3:2 spin-orbit lock, noon to noon lasts 176 Earth days. The sun lingers, the shadows creep at a patient speed, and rocks expand and sigh and then snap as night returns. This thermal breathing opens joints and makes boulders shed splinters, an airless version of freeze-thaw. When sunlight hits fresh material, it darkens and reddens over time thanks to space weathering. Micrometeoroids spray tiny glass beads. Solar wind implants ions into mineral lattices. On Mercury, even aging is a matter of light and speed. The magnetosphere here is pocket-sized. The boundary on the sun-facing side can be only a few thousand kilometers above the surface. That makes magnetopause crossings a frequent event for any spacecraft, and sometimes the barrier opens. Magnetic reconnection, field lines snapping and rejoining, lets the solar wind dump particles directly toward the surface, stirring little storms of electrons and ions that briefly build and then relax. If Earth's magnetosphere is a castle wall with a wide moat, Mercury's is a low hedge with a gate that swings on gusty days. You could imagine life for a machine here. Solar panels that joyfully overperform and then freeze. A radiator that works a little too well after sunset. Instruments wrapped in shielding that doubles as a thermal blanket, peeking out at a world that gives nothing away easily. The speed of orbit makes for quick changes in viewing geometry. The long day makes for patient planning, and the proximity to the sun makes communication a dance of antennas and scheduling. It's not hostile by personality, only by physics, which is more honest than malice. The naming on the map has its own charm. Craters carry the names of artists and writers and musicians. Caloris neighbors Rembrandt and Tolstoy. Other basins nod to Beethoven and Kurosawa. It's not an accident. The convention says, if you get to punch a permanent hole in a place with a rock the size of a mountain, you may as well share the real estate with someone who filled a different kind of space with sound or story. On Mercury, the museums are underground and circular. What's lovely, quietly lovely, is how Mercury makes sense of the two currents we've been following, sunlight and the sun's breath. Without air, sunlight is raw here, nothing but photons and truth. Without a thick shield, the breath of charged particles lands close and writes directly on the surface. The planet didn't ask for subtlety, so it didn't get any. It's a clean testbed for heat, gravity, and magnetism. We learned that gravity curves space by watching its orbit. We learned that crusts can wrinkle when hearts cool by reading its cliffs. We learned that ice can survive a hair's breadth from a forge by peering into polar night. There's a comfort in that honesty. No clouds to pretend, no oceans to argue, no plants to complicate the color. Just a small, dense world being exactly what physics says it should be. And then, like the best students, surprising us with a few extra details. A sodium tail, hollowed pits, and off-center dynamo. If you listen closely at the rim of Caloris, you can almost hear a dry aside. You wanted extremes? You came to the right neighborhood. We'll keep to our pace. The wind presses across your shoulders again, less a push than a reminder. One small world has given up its secrets with economical clarity. Ghost air, hidden ice, iron heart, and the quiet satisfaction of closing a famous math problem with a tiny turn of an ellipse. The sunlight lies flat on the rocks. The shadows are sharp enough to nick your eye, and the sky remains gloriously black above a sun that never learned to whisper. Slip outward one small step, and the light softens behind a gauze you can't peel away. A bright, cloud-wrapped globe rolls into view. So reflective it looks gentle, so polished it feels inviting, and yet the welcome mat is set on a stovetop. Venus keeps secrets under that veil. Not to be dramatic, just to be thorough. The first rule here is that what you see is not the surface. The second rule is that the surface doesn't care whether you see it. You arrive at the ceiling first. The clouds begin high and stay thick. Sheets of droplets made from sulfuric acid hanging in layers like an endless stack of lace soaked in lemon juice. Sunlight threads through, gets scattered and rescattered, and by the time it reaches the ground, it's a dim, syrupy glow. If you look sideways along the tops of those clouds, you'll notice something rude and impressive. The whole atmosphere is running laps around the planet, a super rotation that lurches the winds along at hundreds of kilometers per hour. The ground is so slow that the sky gets bored and goes on ahead. The clouds circumnavigate in just a few Earth days while the planet underneath takes 243 days to make a single spin, and it does that spin backward. If you could see the sun from the ground, you can't. It would crawl up in the west and set in the east like a stubborn movie playing in reverse. Drop through the deck, and the numbers start to lean. Carbon dioxide is the bulk of the air, thick, heavy, insulating. Pressure climbs with each kilometer until, near the surface, it settles at 90-plus Earth atmospheres. The weight you'd feel a kilometer under the ocean. Heat doesn't just arrive, it sticks, bounces, piles up, and stays. The thermometer ends up near 460 degrees Celsius. Lead puddles at that temperature. Zinc size. You can fry the concept of shade. The hottest planet prize doesn't go to Mercury, despite its closeness. It goes to Venus because atmospheres can be bullies when they want to be. You could land a machine down there, so long as you promise not to make plans for the afternoon. Soviet probes did it, descended blind through the clouds, sat briefly, and phoned home pictures that looked like a desert on another Earth that made a terrible atmospheric mistake. Those landers worked for minutes to a couple of hours. Then the world did what it does, and the hardware rested. In that glow, rocks take on a soft-edged look. Basaltic plains spread between blocks of rough, crumpled highlands. Radar, because ordinary light can't get in, shows broad lava flows and puzzles with names like coronae, circular features that look like geology, try to draw a ripple and press too hard with the pencil. Tesserae, tile-like highlands, cross-hatch the crust, hinting at ugly, complicated stress, the sort you get when a planet tries to relieve its interior heat without the convenience of moving plates. Which is another key. Unlike Earth, there's no clear evidence of global plate tectonics. The lithosphere isn't a set of jostling rafts. It's more like a single plate with occasional breakdowns. The planet seems to keep its heat by episodic outbursts. Widespread resurfacing events where a lot of lava comes up and resets the clock in big patches. The surface, in many places, is geologically young, on the order of hundreds of millions of years rather than billions, which is young by planetary standards and very funny for a place that otherwise feels ancient. Signs that volcanoes may still be active flutter through the data from time to time. Shifting sulfur dioxide in the air, heat spots that wink at radar, shapes that look newly broken. The jury keeps taking lunch breaks, but the hints stack up. If you care about time, and of course you do, Venus makes a mess of it in two neat ways. The sidereal day, the time it takes to spin once relative to the distant stars, is 243 Earth days. The year is 225 Earth days, so a day lasts longer than a year. But because the planet spins backward, the solar day, the time between one noon and the next, comes out around 117 Earth days. It's like ordering something simple and then watching the kitchen swap ingredients twice before serving a plate that somehow tastes consistent. The net effect is a sky that would, if you could see it, crawl with deliberate slowness, while the wind higher up rushes on errands it will not explain. If you're waiting for a magnetic field to arrive and tidy up the place, don't. Venus doesn't carry a global one. There's no dynamo humming in the core like Earth's, no big magnetic umbrella to deflect the solar wind. The planet does grow a kind of induced magnetosphere, an electric cocoon built where the wind meets the conducting upper atmosphere. But it's a temporary, flexible thing, not a shield with a spine. The solar wind shears at the edges, and light elements drift off over time. Water, especially, didn't do well here. Ultraviolet light breaks it into hydrogen and oxygen. The hydrogen escapes easily. The oxygen gets busy oxidizing or joining other molecules. The current mix of hydrogen and its heavier sibling deuterium carries the fingerprint of that loss. A hint that Venus may once have hosted more water, maybe even shallow seas before the blanket got too thick and the thermostat jammed on high. You don't have to go all the way down to feel the place, though. At about 50 to 60 kilometers above the surface, pressure and temperature hover near Earth-like, as if a benign floor is suspended in the sky. The clouds are still acid, so you can't exactly picnic, but the air is gentle and the view would be a horizon of cream swirling over a hidden plain. Dreamers like to sketch airships there, slow, buoyant laboratories that would float in the temperate layer, and take pictures with windows that don't immediately corrode. Whether those dreams are practical is a separate discussion. What matters is that Venus contains multitudes. Hell at the ground, a soft pause in the middle, swift cold at the top. Back down in the heavy air, motion gets odd. Winds near the surface are slow, walking pace, but the density gives them muscle. A breeze has the steady shove of a small river. Rocks don't tumble, they confess. Sand doesn't leap, it creeps. If you cover a microphone to protect it from acid and heat and let it listen, you'd record a low, constant hiss, the kind of room tone a planet makes when its air is thick and its light is thick and everything is under a weight that never lifts. Lightning? Reports and hints in radio suggest it happens up in the clouds, perhaps often, but the proof is a collection of sometimes and maybe that fits the general style of the place. Hard to see, undeniable when it wants to be. The radar maps carve out landmarks with names that sound like myths because most of them are. Maxwell Montez rises above the plains like a boss, crouched on Ishtar Terra, the sort of highland that would host snow if snow were a thing here. What passes for bright in radar is rough and possibly coated in odd frost, made of metals that condense under those conditions. Lead or bismuth sulfides have been suggested, but the surface is a heat bath, not a winter scene, so frost is more about chemistry than about comfort. Elsewhere, vast lava plains bear the tracks of floods that happen not in days, but in geologic minutes. Eruptions that smeared basalt across a horizon and let it cool under an air so thick it might as well be a slow liquid. There's a small, needling irony in the orbit and the brightness. From Earth, Venus is the brilliant evening or morning star, a beacon that sailors and poets both use for timing and mood. It looks like a promise. That shine comes from the clouds. The planet reflects most of the sunlight that hits it. If you've ever been catfished by a profile picture taken under perfect lighting, you understand the emotional arc of the probes that went from, oh, lovely to oh no over the course of a descent. The surface chemistry tells you the backstory in a clean, unhurried voice. Carbon dioxide rules. Nitrogen plays second fiddle. Trace gases, sulfur dioxide among them, cycle through the clouds, building and raining out as acid, then evaporating again higher up. The greenhouse feedback is the whole show. More heat locks and more. The air thickens and warms, water leaves, and the cycle consolidates. If you're wondering whether this is a morality tale, you can relax. Planets aren't moral. They're obedient to physics. But the comparison is useful. Earth has plate tectonics and a lively carbon cycle that tucks carbon away in rocks and releases it over long arcs, plus a magnetic field that helps hold the air, plus oceans that moderate the tantrums. Venus had a different hand of cards and played them consistently. The result is a greenhouse you do not visit for tours. Still, there's a sly generosity here. The clouds contain a persistent mystery, an absorber in ultraviolet that darkens certain bands and gives the deck its mottled look from orbit. Candidates exist, consensus does not. It's a small secret held by a very large world, something to argue about gently while the rest of the planet insists on outcomes you can measure with a thermometer and a barometer and a stopwatch. Think for a moment about what slow means here. The sky above you at cloud top height is in a hurry, tearing along with enough energy to make waves and bands you can photograph from space. The ground takes months to rotate once. The day is longer than the year. The atmosphere makes up its own mind and keeps moving even when the rock beneath is basically standing still. The sun would set backwards if you could see it through the haze. There is a tempo to the place, and it's not yours. But if you let it be, it becomes interesting rather than hostile. A reminder that time is a choice as much as it is a measurement. The lack of moons feels like a footnote in an epitaph. Venus has none. No tides tugging. No familiar companion hanging low and changing phase. In photographs of a night, it's often paired with the moon for poetry's sake, but that's our moon, not hers. The planet spins alone and keeps its weather to itself, all hiss and heat and bright disguise. You could call that lonely. You could also call it sufficient. If you step back just a little, you can hold two truths without forcing them to duel. Venus is a cautionary example and a beautiful thing. The greenhouse is brutal, yes, and the pressure is unfriendly, and the sulfuric acid clouds do not flatter the skin. But the cloud deck is gorgeous from above, luminous and structured, with waves that travel in miles-long crests. The air at a certain altitude is shallow breath comfortable. The radar portraits of the ground are a masterclass in how to see with math when light refuses to cooperate. And the planet itself, seen in the evening sky, is the brightest star you can set your eyes on, which is a kind of gift even if you never plan to visit. Remember the way Mercury wore its magnetosphere like a small, tight cloak? Venus wears an invisible shawl stitched by the solar wind, a sheath of induced electric currents that hugs the planet closer than a true magnetosphere would. The wind peels at it, folds it back into a long tail. The result is a steady leak of light, gases, and a quiet conversation between a star and a planet that orbits too close for comfort. Pack these images alongside the numbers, and you'll have enough of Venus to hold without dropping any pieces. A backward spin, a day that outlasts the year, a bright veil, a darkened furnace under the veil, an air so heavy you could almost swim through it if you didn't mind dissolving. You don't leave a place like this with a tidy bow because it doesn't offer you one. You just lift your eyes through the clouds again and watch the sunlight sharpen in the clear space above, then soften as the deck swallows it, and you pay attention to how the mind adjusts. Somewhere outward on a blue and white world with a magnetic umbrella and moving stone and patient water, the same star is writing a gentler script. Keep the hum of slow rotation and quick winds in your ear as you turn. You'll hear the contrast more clearly when the continents start to creak and the ocean answers back. From the pale furnace of Venus, you let your eyes rest on blue and white, on a planet with edges softened by air and the sound of water stitched into its skin. Clouds bruise and brighten across oceans. A swirl the size of a country turns lazily and then unravels into rain. A brown spine of mountains cuts a continent like a seam someone kept meaning to finish. You already know this place by heart, even if you've never left it, because everything about you has been tuned by its light, its seasons, its air. Tonight, we're not doing postcards. We're going to sit with the machinery, the moving stone beneath your feet, and the invisible shield around your head, because that's the quiet heroics of home. Start under the continents, where nothing looks like a map. Earth's outer shell isn't one piece. It's a mosaic of plates that drift, collide, dive, and tear. One plate shoves under another and melts into the mantle. Somewhere else, new crust oozes up along a mid-ocean ridge like batter poured into a long, thin griddle. It's not fast, fingernail growth speed, most years, but give slow motions enough time, and they make mountains, open oceans, and put a fault under your city with the patience of a saint. You live on conveyor belts made of rock. When two belts meet head-on, you get ranges that buckle the sky. When they slide past, you get earthquakes that remind you the planet is a living machine, not a stage set. This is not just geology flexing. It's climate control. Subduction drags carbon down into the deep and locks it into rock. Volcanoes bring some backup and a fine balance that keeps the air breathable over absurd spans of time. Call it the carbon silicate cycle if you like labels. I call it the thermostat that refuses to panic. The reason plates move at all lives deeper still. Earth is layered like a cake that ignores tidy boundaries. A dense metallic core, mostly iron, with a nickel chaser, sits inside, wrapped in an outer shell of liquid metal, and around that a mantle of hot, pressurized rock that behaves solid on your timescale but flows like taffy on geologic ones. Heat from the core and from radioactive elements keeps the mantle convecting. Hot rock rises, cools, sinks, and rises again in slow, stately loops that carry plates on their backs. Think of lava lamps, then dial the speed down until your patience becomes a virtue. The outer liquid iron doesn't just slosh, it churns, and that motion builds something we've been quietly relying on this entire time, a magnetic field. The field isn't a line drawing wrapped around the planet. It's a 3D, lopsided, time-changing web born from electric currents in that liquid iron ocean. It drapes out into space and gets squeezed on the day side by the solar wind and stretched into a long tail at night, a teardrop shield with a humming interior. We live inside that magnetosphere like under an umbrella that also happens to be a force field. Charged particles aimed our way from solar flares and the background hiss of a galaxy get bent and bounced and sent packing. Some get trapped in donut-shaped regions we call the Van Allen belts. Some pour down along magnetic field lines near the poles and light the upper air with auroras that look like curtains waving in an impossible wind. This is space weather with good bedside manners. A little theater, a lot of protection, and a steady reminder that we picked the right planet to install a couch on. You've seen water do tricks. Here it does them all. Solid at the poles and atop high peaks. Liquid in oceans and lakes and veins of rock. Vapor curling through air and turning sunsets gold. On Earth, water is the great negotiator. It carries heat from equator to pole, lubricates plate boundaries, erodes mountains into sand and then into silt, and holds heat when nights would otherwise be sharper. The cycle is a loop that's never quite closed. Ocean evaporates, clouds form, rain falls, rivers run, groundwater seeps, and some of it sneaks back down into the mantle with subducting slabs, only to reappear in a volcano's breath a million years later. No other world we know offers water this way. Everywhere in all three states at the surface, working 1,000 small miracles without asking for applause. If you've ever felt personally attacked by winter, you can blame the tilt, not the distance to the sun. Earth leans about 23.5 degrees relative to its orbit. That tilt decides where sunlight lands most directly, how long days stretch, and when shadows get long enough to make your morning commute feel like a movie. It's why one hemisphere wears summer while the other tucks in under blankets. The orbit's ellipse adds a small accent. The planet is a bit closer to the sun in January than July, but the tilt composes the melody. Without it, you'd live under a mild, tedious sky. With it, you get spring evenings that feel scientifically blessed. While we're admitting to stats, Earth is the densest planet in the solar system, packing about 5.5 grams into every cubic centimeter on average. That density isn't just trivia. It explains the strong gravity for our size and the iron core capable of running that electromagnet for billions of years. Heavier elements sank early, lighter ones floated, and the whole thing differentiated into layers like a cocktail that looks great in a clear glass. The result is a planet sturdy enough to hang on to a thick atmosphere and delicate enough to let light scoop blue out of the white mix and scatter it into your sky. Now the moon. We give it poetry because it deserves it, but mechanically it's doing serious work. It is large, unusually so for a rocky planet. 1/4 of Earth's diameter and 1/7 of its mass, more like a companion than a pet rock. Tides are the obvious show. Oceans bulge toward and away from the moon, and the continents get a subtler tug you can't see, but can measure if you're the sort of person who puts GPS on bedrock. That endless tug-of-war drains a whisper of energy from Earth's rotation and hands it to the moon's orbit. The moon inches away by about 3.8 centimeters a year. Our days lengthen by milliseconds every century. In the deep past, days were shorter, the moon was close enough to look smug in the sky, and total solar eclipses were more common and more dramatic. In the ridiculously far future, eclipses will thin out. You're living in the sweet spot where geometry makes perfect circles of shadow on demand if you stand in the right place at the right time and refuse to blink. The moon's steadying effect matters for seasons too. That big companion damps wild swings in Earth's axial tilt. Without it, gravitational nudges from the other planets could tip us into more chaotic climate swings. With it, the tilt wanders but slowly and within civil limits. The result is a climate that breathes rather than gasps, a gift to anything that needs centuries of relative stability to figure out photosynthesis, invent bones, or teach itself to write bedtime scripts about stars. Your air is a tapestry woven over time. Early Earth likely wore a different mix, volcanic breaths, no oxygen to speak of, until life itself learned to split water and exhale O2 as waste, which is the most on-brand life story there is. Turn poison into air, then paint the surface with rust and build an ozone layer to block ultraviolet. Today, nitrogen dominates. Oxygen keeps you comfortably flammable, and trace gases tune the greenhouse, so the average morning doesn't wear a parka. That greenhouse is delicate, it can be nudged. But the long geologic cycles and the short biological ones overlap to make feedbacks that, when left alone, tend to circle back to room temperature. It's weird to think that breathing and mountain building are part of the same thermostat. But there you are. Every lungful is a tiny vote in a planetary committee meeting that's been in session for billions of years. The field outside and the plates underneath cooperate in ways you don't often see in the same sentence. Volcanoes belch gases that change the air. Weather scrubs some of them out. Rivers carry ions to the ocean. Tiny creatures build shells and lock carbon into limestone. Subduction carries that stone downward to be cooked and, eventually, exhaled again. Meanwhile, the magnetosphere swats away much of the charged particle rain that would otherwise chip at the atmosphere and rough up DNA in ways no creature appreciates. Even the messy parts, the storms, the quakes, are signatures of a system running hot enough to keep oceans liquid and continents moving, but cool enough to avoid catastrophe most days. On Earth, the chaos is curated. For a planet with one big satellite, Earth shares surprising space with smaller companions you never see. A few co-orbital asteroids play tag on horseshoe-shaped paths that keep them near our orbit without falling into it. Some hang around gravitational parking spots called Lagrange points, drifting ahead of or behind us like thoughtful joggers who refuse to pass. They're small, and many are temporary house guests of gravity, but they belong to our neighborhood. They remind you that empty space is always carrying more friends than you expected. At night, if you slip somewhere truly dark, the sky offers a version of the magnetosphere's art. When the sun sends a rude packet of particles and the field guides them down near the poles, the upper air glows. Oxygen sings green and sometimes red. Nitrogen adds violet and blue. The arcs ripple and fold like the curtains a careful stagehand keeps lifting and dropping just to watch them fall. It's easy to get mystical about it. The practical part is nice too. That glow is a symptom of the shield doing its job, a space weather forecast you can read without knowing what a proton is. If all of this sounds suspiciously like bragging, it's only because habitability is a team sport and this planet has a deep bench. A moving mantle gives you continents and coasts that refuse to fossilize into one permanent arrangement. A magnetic field guards your breath. Water in all three flavors lubricates the entire show. The moon keeps time and tides. The tilt paints the year. Even the fact that you can walk outside and feel your weight pull you down, a consistent, reassuring tug, owes something to that dense interior. You carry iron in your blood that used to live in old stars. The planet carries iron in its heart that keeps drawing a line between inside and out there. If you want to test the kindness of the place, step into a desert after the sun sets and listen. Not with your ears, though crickets are out there making little metronomes, but with the part of you that notices how fast stone gives up heat. On Earth, air lingers. It takes the day and gives it back slowly. Water holds on even longer, spilling warmth into night and pulling cool into morning. That lag is the difference between a world where evenings invite you outside and one where the darkness is a hard wall. You live inside the lag. It's one of the reasons a fan's soft hum can make you feel safe. We keep clever instruments in space to watch all this. Not because we doubt it, but because nuance matters. Satellites read the magnetic field's wiggles and map the plates creep from the sky. Others measure the thickness of ice and the height of the sea and the moisture in the air. None of that breaks the spell. If anything, it sharpens it. Knowing that your planet's heartbeat runs through a dozen different systems just makes the rhythm easier to relax into. When you close your eyes tonight, gravity will still be grounding, the core will still be churning, the plates will still be arguing in their slow, grinding way, and the field will still be holding its palm up to the wind from the sun somewhere near the poles. A faint green ribbon might be waving. Somewhere in the tropics, a storm might be organizing itself out of warm water and ambition. Somewhere under the ocean, basalt is cooling, and somewhere under a mountain range, rock is flowing like warm caramel. You don't need to track any of it. You just have to know it's there, making the place you sleep an address worth memorizing. And if you keep one image in your pocket as we step back into space, let it be something simple. Your hand on a windowsill warmed by morning sun. The pull of your weight reminding you you're attached to a very specific ball of rock. A quiet knowledge that under the kitchen tile is a slab riding a conveyor belt the size of an ocean. And above the roofline is an invisible umbrella built by a sea of liquid iron. The grandeur is real, but it's not loud. It's the kind that keeps the lights low and the room at a soft, steady temperature while you settle into the next part of the story. From ocean blue and auroral green, you step into rust, into a quieter light where the sky runs thin, shadows lose their blur, and every edge looks honest. Mars doesn't do lush, it does clarity. The air is so spare you can almost count it, a breath that wouldn't fill a paper bag, and yet the place wears weather the way a violin wears music, softly most days, then suddenly loud. Under this pale ceiling, the colors go simple, brick, basalt, frost, and the scale refuses to stay polite. The first thing that steals your sense of size is the scar. Valles Marineris isn't a canyon so much as a decision. A gash more than 4,000 kilometers long that would stretch from coast to coast if you laid it across the United States. In places it drops 7 kilometers or more, a fall deeper than 5 Grand Canyons stacked, with terraces and landslide tongues and fretted walls that look hand-chiseled until you remember the hand was tectonics, lava, and time. Stand at a rim in your mind and lean forward. The far wall looks like a horizon. The floor is a continent away, and the air in between is too thin to carry any sound of the rocks that occasionally let go and rush the slope. Why a wound this big? The short version, the planet tried to stretch. The longer one, heat and internal stress pulled at the crust while giant volcanoes rose nearby, and the top layers fractured and slumped. On Earth, moving plates would have spread the strain across a long argument between continents. On Mars, without that conveyor belt system, the land had nowhere else to send the tension but down. Erosion came later, with trickles of past water in places and long, patient work by wind, but the first draft was tectonic stretching and volcanic weight. Mars laying open its middle and then living with the result. Look northwest, and the horizon bulges like the planet is hiding a shoulder under a blanket. That rise is Tharsis, a broad swell of crust fattened by magma. And parked on it is something that should be impossible until you count the reasons it isn't. Olympus Mons, the tallest volcano in the solar system. It climbs nearly 22 kilometers above the plains, almost 3 Everest stacked, with a footprint that would blanket a small country. Its flanks are gentle, the way shield volcanoes are, built by countless fluid lava flows that ran for miles before cooling. Its edges end in scarps where the whole structure crept and the crust said enough and broke away. On Earth, a hot spot wanders under moving plates and builds a chain of islands like Hawaii. On Mars, the crust stays put. The hot spot keeps feeding the same vent. The mountain grows absurd and then keeps a straight face about it. Everywhere you look, the red is honest. Iron in the rocks met the meager oxygen in the air and in the past water, and it made rust. Not the flaky hardware store kind, but a fine, persistent dust that creeps into every seam and turns every landscape into a postcard with one dominant crayon. That dust is so fine it floats for days. It scours and polishes. It paints the sky with a soft tan in daylight and gives sunsets a copper heart. Weather here is a catalog of what dust can do when the air is too thin for real clouds to bully the scene. And yet there are seasons. Mars leans on its axis by about 25 degrees, close to Earth's tilt, so sunlight shifts north and south through the year, and the poles take turns in brightness. Winter grows a hood of dry ice as carbon dioxide freezes out of the air and plates itself onto the polar cap. Spring turns up the light, and the CO2 sublimates back into vapor, warming and stirring winds that lift dust and write curls and streaks across satellite photos like calligraphy in beige ink. Summer hands the southern hemisphere a little extra drama because Mars is closer to the sun then, and sometimes the local dust shows go national. Those are the storms you've heard about, the ones that begin like a whisper on a warm afternoon and, given the right feedback, build into a wall that wraps the planet. The dust absorbs sunlight, warms the air. That warmer air lifts more dust, and the loop feeds itself until orange spreads over everything. Sunlight dims, solar panels sulk, and a rover with a name like a virtue sits and waits for the sky to clear. In 2018, the wait ran long, and the little machine called Opportunity went silent under that veil. There was no tragedy in it, just physics and a mission already long past its promised span. But if you want a clean picture of Mars weather, that's the picture. Fine grains, global reach, and endings that are quiet and dignified. Up close, the ground is a mix you can read with your eyes, even if you've never cracked a geology text. Basaltic plains from old lava flows, battered by ages of micro-impacts. Craters with central peaks where the surface rebounded like a struck drumhead. Dunes pushed into scallops and snakes by winds that never get tired. In some places, sinuous channels and layer deposits tell you water once had at least a cameo role. Brief flows that carved, pooled, froze, or evaporated, but the world isn't watery now. The air is too thin to hold much heat. Liquid water would boil and freeze almost in the same breath. What remains is ice locked in a soil at high latitudes and hidden under dust, and frost that paints a morning and then slips away. The planet remembers oceans the way an old house remembers a wallpaper pattern. In ghost outlines, if you know where to look, not in the scent of fresh paint. The thinness of the air does more than chill you. It changes how height feels. Climb a hill and your lungs vote no sooner than they would at home. Drop into a canyon and the sea level you carry in your head goes wonky because there's so little pressure to change in the first place. Sound doesn't carry far. A shout would be small even if you had a mouthful of oxygen to feed it. The horizon is close, but the distances fool you because there's no haze layer to tell your eye about depth. Everything looks near until it isn't. With no global magnetic field to lean on, Mars takes the solar wind on the chin. Patches of crust still carry fossil magnetism, relics of an older dynamo that went silent long ago, but they don't make a planet-sized umbrella. The wind eats at the upper atmosphere molecule by molecule, strips the lightest gases most easily, and leaves isotope ratios that give the slow theft away to anyone with an instrument and patience. It's a leak, not a rupture, but over deep time leaks matter. The planet that once held on to thicker air and friendlier surface water lost some of that grip. Now it wears a cold grin and saves its warmth for rocks that sit in sunlight. You can't talk Mars without talking moons. And here the story goes small and odd. Phobos and Deimos aren't round, majestic partners. They're the lumpy cousins who arrived late, misshapen, cratered, likely captured from the asteroid belt long ago or born from impact debris that forgot to leave. Phobos orbits so close it rises in the west and sets in the east, a fat potato moving too fast for comfort, and it's slowly spiraling inward. One day, give it millions of years, it will break into a ring or find the ground the hard way. Deimos is shy and outward bound, inching away. They look like practice moons, like gravity was doodling in the margins and left 2 sketches pinned in place. Every so often, Mars sends us a postcard in stone. A violent impact blasts chunks off the planet. A few pieces wander into Earth's gravity months or millennia later and fall as meteorites. Some carry tiny bubbles of gas whose chemistry matches the air as measured by landers, which is the universe's way of initialing its work. Others show minerals that remember past water by the shapes they form and the atoms they trap. If holding one makes you think of wind on a red plain and a cold morning with a small sun, you're not being sentimental. You've just read a rock accurately. The planet keeps time in its own units, with a day a sol just a little longer than ours, and tapestries its surface with reminders that the clock is slow and the hand is steady. Erosion more by wind than water. Frost heaves that moves soil grains with patience. Avalanche streaks that appear on dusted slopes in spring, like the world is tidying up winter one slide at a time. None of it wishes you harm. All of it is indifferent. That's the comfort. Here, the drama is honest, and the poets have to bring their own metaphors. If you prefer mechanics, here's the clean picture. Mars did not build plate tectonics the way Earth did. The crust is a single lid with cracks and bulges instead of a puzzle of moving rafts. That means heat leaks in pulses, not on a conveyor, and mountains can sit over a hot spot until they tower without shame. The lack of a lasting dynamo means less shielding and a greater role for the solar wind in trimming the air. The tilt hands out seasons. The eccentric orbit adds a little asymmetry, and dust takes every opportunity to steal the scene. All the pieces fit. The result is not chaos, but a different kind of order. And yet it's not still. Mars quakes, faintly, but enough to prove the interior isn't entirely asleep. In the polar night, the CO2 cap creaks as it thickens and sighs as it thins. In summer, dust devils wander the plains, drawing thin chalk marks across a red board and then erasing themselves. Morning frost glitters and then vanishes. Shadows stretch and shrink. A rover's tracks soften into the common texture of windworked soil and then fade. You can fall in love with a planet for less. Take a last look at the canyon's rim in your mind, then at the slope of Olympus Mons where the horizon curves gently under your boots. Watch a brown storm bloom in the distance, and think of the time it swallowed the globe and put a small, patient robot to bed. Imagine the 2 little moons as dots tugging at the sky, one rushing, one hesitant. Think of a piece of this world falling here and being picked up by hands that smelled like Earth's air, then ground and studied until its story crossed with the data beamed from orbit and from planes half a sky away. We're keeping the same pace, the same soft voice you can follow without effort. Ahead are places where gravity gets grander and storms grow stripes, where radiation belts snarl and moons multiply until a planet looks like a miniature solar system. As you lift off this red plain, dust still in your cuffs, the light begins to strengthen and a broad, banded world gathers on the far side of your imagination, waiting with a spot the size of 2 Earths and a magnetosphere that would swallow ours whole. Slip outward from the rusted silence of Mars, and you find space growing wider, not fuller. Popular movies promised a gauntlet of tumbling boulders. The reality is a hush. The asteroid belt doesn't crowd the lane. Most of it is empty room with a few million small, ancient things spread so thin you could steer a door through it and miss everything for a lifetime. That's its first trick. It's vast, sparse, and patient. A museum whose exhibits are mostly labels hanging in the air until you lean in close. Lean in then. The light here is clean, the shadows firm. Ahead sits a world that refuses to choose between categories. Series. Round enough to earn the dwarf planet badge, small enough to live among rubble. From a distance, it's the color of a winter road. Up close, parts of it flash like spilled salt. Those bright patches are deposits of sodium carbonate and other salts, white freckles in dark bowls, especially in a basin with a name that sounds like a spell, Acator. If you were expecting ice, you weren't wrong. Water has been the quiet sculptor here. Even this far from the sun series hold a lot of it as hydrated minerals and slush locked under rock, and some of that briny water has oozed upward in the recent geological past, then dried to leave those luminous stains like the memory of tide. Picture a cold, slow cryovolcanism. Not lava, but salt water rising through fractures, flashing into vapor under low pressure, and leaving a crust that catches sunlight like a wink from a reserved neighbor. Ceres wears its age on a round face. Craters layered on craters, soft-edged where ice and time have relaxed their rims. In a thin gravity like this, mountains slump and plains keep their secrets. The surface chemistry is a gentle table of contents. Carbonaceous materials, hydrated minerals, hints of organics that aren't life but would happily sit on a shelf marked ingredients. You don't come here for spectacle. You come for context. Ceres is what happens when a solar system starts to build a planet and then stops for lunch. Round, layered, what enough to be interesting, not busy enough to erase its notes. Slide your gaze along the belt, and the mood changes. Vesta comes at you with sharper bones, the look of a world that got halfway to planethood and decided to keep the core. It's not round the way Ceres is. It's squashed and scarred and confident, a protoplanet that sorted itself into a metal heart, a rocky mantle, and a crust before the neighborhood ran out of patience. The South Pole wears a basin you can't ignore, Rhea Silvia. So large it turned the axis into an anecdote, so deep it may have popped the crust like a blister and bared fresher rock below. The rim is a wall of mountains. The floor is a map of impact melt patterns that froze in place like glass puddled on a cold day. Vesta's surface changes color in a way painterly people love. Bright regions of fresher basalt, darker swaths where space weathering and mixing have dimmed the palette. Meteorites that fell to Earth carry its signature in their composition. Hold one, and you're palming a shard of a planet that never quite was, a layered body frozen mid-sentence. There's something comforting in that, a reminder that almost is still a place with texture, gravity, and a story that clicks into Earth's rock cabinet with a tidy label. Between, beyond, and all around are the small ones, the irregulars, the chipped and the stitched together, the families bound by similar orbits that hint at some parent body's bad breakup eons ago. You expect rocks, you find puzzles. Some asteroids are monoliths, single boulders with dents. But many are not rocks, so much as gatherings, rubble piles, loosely packed assemblies of stones and dust held together by gravity that would lose an arm wrestle with a backyard trampoline. Their densities give the trick away. Their surfaces finish the tale. Boulders stacked like a wall at a farm. Fine regoliths slump between them, craters that look too shallow because the walls sagged as soon as they formed. Tap them hard enough and they ring dull. Spin them a little faster and the equator puffs outward, a fat belt of gravel where loose bits have migrated under the whisper of centrifugal force. It feels impolite to talk about fragility in a place famous for impacts, but that's the lesson here. Strength isn't a default. Many of these bodies are more like held hands than clenched fists. When sunlight heats one side and re-radiates at night, the tiny push can act like a long, low-pressure thruster. Over years, that thermal nudge, day after day, photon by photon, can spin an asteroid up or slow it down. Push too far and pieces wander off, either to form a moonlet or to drift into space like an absent-minded shrug. The sky is quiet about it, but the math is stern. Speaking of moons, the belt loves partnerships. Some asteroids carry satellites, little companions that circle so closely you'd miss them unless you were paying the kind of attention that gets you teased at parties. The first one we spotted up close was Dactyl, lapping around the larger Ida, a small rock bound to a bigger one, gravity's version of tetherball. Other pairs are true binaries of near equal size, whirling around a common center like two skaters holding hands. You can feel the dance more than see it, a drift, a pause, a gentle tug, repeated for millennia until some outside nudge changes the tune. These arrangements are lessons in how messy formation can be. Not every moon was born with its planet. Not every pair started as one. A few of the belt's citizens are dark as coal and reflect so little light that you only notice them when they erase stars as they pass. Others gleam a little more, worn bright by composition or by the kind of recent surface change that hasn't had time to fade. There are metallic bodies, the stripped cores of bigger things, probably and stony ones, and hybrids with veins of each. There are families, Eos, Themis, Flora, groups that cluster in orbital space because they are chipped from the same ancestor. If you've ever swept a workshop floor and recognized the remains of a particular project in one corner, you know the feeling. The belt as a whole is less massive than the moon, a fact that should make you blink given the number of names you can pin on a sky chart. Most of the stuff that could have made a planet here never did, distracted and stirred by Jupiter's gravity. The giant's rhythm carves gaps into the population, places where orbits are less stable because they keep catching the same beat from a drummer with a very large kit. You can even see the empty lanes and histograms, dips at certain distances like missing teeth in an otherwise healthy smile. It doesn't take a violent collision to clear a region. Sometimes all it takes is a regular, polite nudge at the right moment, repeated for a few million years. Passing through this neighborhood, you realize how often we learn big truths from small rocks. When a spacecraft sidled up to a rubble pile and eased out a robotic arm to take a pinch of surface, it found a world that flowed like dry snow under the scoop. Another probe shot a small pellet into the ground to puff material up and then skimmed away with the dust, the way a chef taps flour into a bowl. Those samples came home, tucked into capsules that looked like jewelry boxes for stardust, and inside were grains older than Earth, unprocessed enough to whisper about the cloud of gas and grit that came before any planet had the courtesy to exist. If your pulse quickens at a teaspoon of history, you are exactly the right kind of human for this part of the sky. Not all firsts required samples. Long before, a passing spacecraft caught a world with a tiny moon in its camera, and suddenly asteroids have moons went from a weird bet to a line in a textbook. Later, another mission orbited two, mapped their mass by the way the path swayed, and taught us how to weigh stones without a scale. One day more recently, a little kinetic visitor smacked into a moonlet and trimmed its orbit by a small, measurable amount. It wasn't malice. It was a demonstration that momentum is a tool you can hold and aim. In a quiet belt where change is slow, a deliberate tap echoed loudly in the numbers. There's weather here, in a way, space weather, not clouds. The solar wind buries ions in the topmost grains. The sun tans minerals until they darken. Micrometeoroids pepper surfaces with tiny glass spherules that give regolith a soft, clingy character. On bodies with almost no gravity, a static charge can make dust levitate and hop, a lazy ballet of electrified flour across boulder fields that haven't moved in eons. If you've ever rubbed a balloon on a sweater and seen your hair lift, stretch that image to a landscape and slow it down by 6 orders of magnitude. That's the aesthetic, very delicate forces working overtime. It's easy to call the belt a junkyard. It's more honest to call it an archive. You can walk each shelf in your head and pull out an exhibit. Ceres with its salt-bright stains and whispers of internal brine. Vesta with its layered interior and South Pole crater that practically shouts, "I was almost a planet." Rubble piles that drift when sunlight thinks too hard about them. Paired stones swirling like skaters. Metallic hearts still wearing the scuffs of their birth. The belt won't serenade you. It will offer something better, provenance. Every so often, a slab is kicked onto a crosswalk and wanders inward. Most die in the upper air of a larger world, lighting a few seconds of sky. A few survive to be found on ice or in desert and pass from hand to hand with the kind of reverence you usually reserve for photographs. Those pieces trail family trees in their elements and isotopes, up to and including matches with a parent body we've mapped. It's a strange feeling seeing a piece of Vesta on a lab bench and a picture of Vesta on a screen and realizing they are, with no poetry needed, the same place in two forms. If you were flying, truly flying, you'd spend most of your time between this rock and the next, between one faint path of dust and another, between names. That's why the emptiness matters. It's not a disappointment, it's the medium. Space leaves room for orbits to be, for gaps to form, for families to cling together across eons. The belt is a lesson in how little you need to tell a complicated story. A handful of sizes and spins, a big planet keeping a loose beat just beyond, sunlight nudging, time doing its deep, tireless work. And there, just past the last of the obvious markers, the light strengthens again into bands. The black bites deeper between stripes the color of coffee and cream. A storm the size of continents turns under a pale oval that has been angry longer than your language has been writing things down. We are approaching the first giant, where storm means centuries, where magnetosphere means bring extra shielding, where moons means enough to sort into categories. You can keep the belt with you as we go. The quiet salt, the layered core, the stones that barely hold together, because the next world gathers small worlds the way a tree gathers birds, and everything we just learned about companionship and gravity is about to get louder. You're close enough now that bands appear before the planet does, like the sound of surf reaching you before you see the shore. Jupiter isn't a sphere so much as an atmosphere with a gravity problem, a striped leviathan spinning so fast that its waist bulges and its clouds shear into lanes. The colors are coffee and cream with cinnamon swirls, zones pale and rising, belts darker and sinking. Each lane of jets stream hundreds of kilometers wide, flowing east, then west, then east again in a rhythm your eyes can't help but follow. You already know the rule here. If air can move, it will. If it can make weather, it will not be shy. The scale clips your sense of proportion on purpose. Those soft swirls you could cup in your hand are continents across. The small, bright outbreaks that pop along belt edges like flashbulbs are storms the size of countries, punching into upper cloud decks with lightning that would humble an entire terrestrial thunderstorm complex. The topmost clouds are ammonia ice, white where they pile tall, and underneath them sits a layer stained by chemistry, ammonium hydrosulfide and other compounds, which paints the browns and reds. Deeper still, water clouds form where warm updrafts drag vapor high enough to condense. The planet doesn't have a surface you can stand on. It has a stack of weathers, and somewhere below the last cloud, the gas simply thickens into fluid and then into exotic forms of hydrogen under pressure you measure in mind-bending adjectives. Spin is the tempo. Jupiter turns once in roughly 10 hours, a day so short the equator stretches outward into a fattened band while the poles stay closer to the center. That spin carves the atmosphere into its lanes. Where bands meet, shear breeds eddies, and eddies breed storms that merge, split, and evolve with chess player patience. White ovals twist along like pearls on a string. Brown barges appear and fade. The planet never repeats itself, but it always rhymes. And then there is the spot. The great red spot sits like an eye half closed against a bright sky, a storm that has spun in the southern belts for at least 3.5 centuries. First recorded when telescopes wore wooden bones and astronomers signed their names with ink that bled. Today it's smaller than it once was and a little less crimson than in some eras. But the wind around it still screams beyond 400 kilometers per hour. The clouds within still dig deeper than their neighbors, and the whole thing remains a monument to persistence. An anticyclone larger than Earth, roaring in a world where storms are architecture. Jupiter glows with more than sunlight. It releases more heat than it receives from the sun, its vast bulk still slowly contracting from formation. Gravitational energy turning into warmth the way a clenched fist turns tension into heat. That inward squeeze makes an outward difference. It fuels convection from below, gives storms a nudge, and keeps the interior restless. If you could see by warmth alone, Jupiter would be a dim ember under its own weather. Not a star, but certainly a furnace with opinions. Drop in gently, the way you always do in your head, and the clouds turn from familiar to abstract. At some depth, the hydrogen stops behaving like the gas you think you know and flows as a metallic liquid. Electrons freed to move, electricity welcomed like a new language. In that layer, a planetary dynamo hums. Charge flows and rotation cooperating to build a magnetic field that refuses to be small. The result drapes space with invisible architecture. Field lines arc and twist, trapping particles and sending them wheeling in hoops around the planet. Light enough to dance, dangerous enough to melt unshielded circuits without apology. That magnetosphere is the largest persistent structure any planet owns, an asymmetric bubble pressed flat on the dawn side by the solar wind and trailing a tail that streams for tens of millions of kilometers downwind. If it glowed, you'd never call the night sky empty again. The auroras here are not shy curtains. They are crowns, permanent, bright, and fierce, ringing each pole where electrons plunge into the upper atmosphere and make hydrogen sing in ultraviolet and infrared that human eyes can't catch without help. Space is loud here, if you translate it. Radio emissions crackle as electrons surf along magnetic ripples, a chorus that has been recorded and turned into audio low enough to feel in your ribs. Inside that field, radiation belts make a moat no fairy tale hero would cross lightly. Charged particles, electrons and ions, are trapped and whipped to energies that make a Geiger counter sound like bead rain on a tin roof. The belts bloom and shift with Jupiter's magnetic weather, thickened by contributions from a volcanic moon you'll meet properly in a moment. To work here, spacecraft bring armor and humility. Trajectories are chosen like hiking trails that skirt cliffs, and instruments nap when the storm gets rude. In the safer high latitudes, a brave craft can skim close, reading gravity's harmonies and sampling the topmost clouds, then climb out again with its memory full and its shielding warm. Lift back to the cloud tops and look again at the bands. They aren't static stripes painted on a globe. They are rivers of air fed by deep cells you can't see, guided by the Coriolis force from that frantic spin. Where belts rise, you get bright ammonia ice. Where air sinks, you get darker lanes that reveal deeper layers. Breaks along the belt edges spawn vortices. And those vortices, like little cousins of the spot, sometimes merge, growing large enough to earn names and lineages. Jets migrate slowly north or south over years. Color deepens, then fades. Chemistry evolves with sunlight's touch, and with upwellings from below that carry differently mixed gases upward to bleach or blush in the glare. Lightning lives here too, wilder and deeper than you expect. From orbit, flashes flicker along night-side cloud tops, especially in the equatorial belts where convection is strong. In the water cloud layer below the ammonia haze, droplets and ice collide, electrify, and discharge in bolts that leap vast gaps. Some flashes are so powerful they could light a city if they weren't busy ionizing a storm the size of a continent. Each burst is a small, sharp admission. Despite the scale, despite the alien chemistry, weather is weather. The planet wears rings so faint you'd miss them if you blinked. They are made of dust, replenished by micrometeoroid strikes on small inner moons, tenuous and dark, a set of diaphanous veils rather than anything a poet would go on about unprompted. From the right angle, with the sun behind, they outline the planet in a thin halo that's less glory than whisper, a detail you tuck away and later mention like a secret. Jupiter's gravity runs a school for company. The four big moons, Io, Europa, Ganymede, and Callisto, write their own epics, and we're almost to them. For now, their lights moving in clockwork out on the dark, points that line up and slip behind the planet in transits that make little black pearls crawl across the bright bands. Beyond those four, dozens of smaller irregular moons keep looser schedules on tilted, eccentric paths. Some go with the spin, some sulk backward. Many are probably captured leftovers from the early chaos, nudged into place by gravity the way flotsam collects in an eddy. Farther out still, ahead and behind the planet in its orbit around the sun, swarms of Trojan asteroids hang at stable balance points. Not moons, not rings, but attendants nonetheless, clustered like commas in the planetary sentence. You've met magnetospheres before. Earth's compact umbrella, Mercury's tight hood, Venus's induced shawl. But Jupiter's is the cathedral version, all high vaults and echo, an interior so large it includes other worlds. The radiation belts are fed by Io's volcanoes, whose plumes fling sulfur and oxygen into space. Those atoms are ionized and whipped into a donut-shaped cloud that circles the planet, the Io Taurus, glowing in wavelengths our eyes don't see. The field lines thread those plasmas like harp strings, and waves run along them, shuttling energy from moon to planet and back in ways that make auroras brighter and instruments grin. If you want another sense of scale, count the storms. Not one, not a dozen, but hundreds. White ovals, brown ovals, little barges, cyclones at the poles organized into geometric patterns that look like someone tiled the atmosphere. The poles are their own weather, far from the stately bands of the mid-latitudes. There, compact cyclones gather into rings around a central vortex at each pole, each storm a coherent beast that keeps its shape while it wrestles with neighbors in a slow-motion ballet. The geometry forms, persists, and shifts with a stubborn grace, like ice disks bumping in a slow river if the ice disks were made of cloud and ambition. Jupiter's gravity is so strong it writes music into passing objects. Comets that wander to, near, can be torn or redirected. Asteroids feel the tug and find new families. The planet's presence has helped shape the architecture of the solar system since the beginning, sculpting the asteroid belt's gaps by resonance, hauling some bodies inward, flinging others outward. When you speak of the solar system story, you're speaking, in part, of Jupiter's editorial choices. Everything you've learned about space, weather finds a louder key here. The solar wind presses, the magnetosphere swells and responds. Currents flow along field lines. The auroras answer with brightness that barely flickers. Bursts of particles, some born in the field, some carried on the wind, slam into trapped populations and change their energy like a DJ shifting pitch. The planet is not passive. It rotates inside its own field and drives electric currents that couple to the atmosphere, a generator the size of a small star humming along at nearly 10 hours per rotation, throwing off radio beams that sweep the void like the quietest lighthouse you've ever failed to hear. If you listen to how spacecraft behave here, you can almost feel the place. Orbits go polar to duck the worst of the belts, skimming over poles to glimpse the geometry of cyclones, and then jumping back outward before the radiation can write too much in memory. Instruments designed to sip sunlight keep their exposure short during bright passes because reflected light off the tops of ammonia clouds can be brutally honest. Panels and processors hide behind slabs of shielding, and teams on the ground speak of parahoves the way climbers speak of summits, with respect and a little restraint. You could stare for hours at a single belt edge and not exhaust it. Edges roll like surf scum bled with foam. Small eddies along where shear is highest, and filaments stretch and break like taffy pulled with too much enthusiasm. Subtle color changes mark where chemistry varies. Thin, bright plumes mark fresh convective bursts. The planet teaches patience. Pick a spot, watch the flow, track the change, repeat, and accept that your clip of time is a sip from an ocean. Carry forward one tidy thought. Jupiter is a world whose weather is the world, and whose magnetic field makes space in a part of the planet. It runs hot enough inside to help feed its storms, spins fast enough to braid its winds, and holds court over a retinue so large you count by categories, not by names. The stripes that first appeared at a distance are now lanes with rules. The spot that looked like an emblem is now a living storm with a biography. The space around Jupiter is no longer a void but a bright, unseen medium laced with fields and particles and messages. Keep your breath slow. The next steps are small ones on the scale of orbits, but large ones in the scale of stories. Because waiting just off the belt edges and beyond the ring's whisper are worlds that are not planets at all and yet matter as much as any. A volcanic moon that never sits still, an ice world with a cracked shell and an ocean below, a giant moon with a magnetic field of its own and the hint of stacked seas, and a dark, old surface that may hide quiet water beneath. The mini-system has weather, heat, and time enough for them all, and we'll visit them one by one without changing the tone or the pace. The bands fade to the edge of your vision, and 4 points step forward like lanterns on a black lake. They move in rhythm, tugging one another, tugging the planet, tugging your attention until the stripes behind them become background and the story splits into 4 quieter rooms. The first door opens on heat, the second on water, the third on magnetism, the fourth on memory. You don't have to choose. The lap of gravity here plays a 4-beat measure. Io, Europa, Ganymede, Callisto, and the time signature is tidal. Start where the metronome runs fastest. Io circles closest, locked in a 4:2:1 resonance with Europa and Ganymede, which means for every 4 orbits Io makes, Europa makes 2 and Ganymede makes 1. That clockwork won't let their paths relax into perfect circles. Eccentricity stays pumped, and with each lap Jupiter squeezes Io and then lets it go like kneading a stubborn dough. Rock does not seem like something that wants to flow, but over a whole moon it does. Friction turns that flex into heat, and heat turns into volcanism that rewrites the surface as quickly as it can cool. Io is the most volcanic body you can reasonably point at. Its plains are splashed with sulfur in shades you'd find in a painter's drawer marked citrus. Its calderas glow with lakes of lava that crust, break, and crust again, and its plumes, some hundreds of kilometers high, make geysers of thin vapor and dust that hang in the moon's weak gravity before falling like slow snow. You can watch a plume catch sunlight at the limb and see it as a faint umbrella, a soft arc above a world that refuses to sit still. Each eruption feeds space with atoms of oxygen and sulfur that quickly lose electrons and join Jupiter's magnetospheric ballet. The donut-shaped cloud that forms, the Io Taurus, glows in wavelengths your eyes can't catch, a silent neon sign advertising that geology has consequences in space. Follow the field lines down to Jupiter's poles, and the current's endpoint leaves a bright footprint in the aurora, an oval within an oval that marks, in light, the electrical handshake between a moon and its planet. It's strange and satisfying. A volcano could draw a picture on a giant sky. Step 1, orbit outward, and quiet falls like snow on glass. Europa is smaller than our moon and brighter. Its face is a jigsaw of ice plates crosscut by dark lines, as if someone dragged a charcoal pencil across a frost. Those lines, lineae, come in double ridges and braided bands, flanked by aprons of stained material that probably began as briny slush squeezed upward and spread sideways before freezing again. The surface is young by crater count, broken and patched and broken again. When you see chaos terrain, blocky rafts of crust tilted and frozen in place, you get the feeling of a shattered lake that never quite refroze flat. The evidence for an ocean below the ice doesn't shout, it accumulates. Europa moves through Jupiter's changing magnetic environment, and the way a secondary magnetic signal is induced tells you a salty, electrically conductive layer sits beneath the shell. The surface flexes with the tide. Heat from that flex rises through the ice. Certain spots glow warmer than others. Chemistry on top picks up oxidants made by radiation and could, in principle, ferry them down through cracks to feed reactions in the dark sea. Questions grow where hints align. Thickness of the ice, vigor of the tide, the plumbing that might connect surface to ocean. Talk of ice tectonics shows up in careful voices. Blocks that move, crust that subducts, because some patterns look like plates passing one another and diving. If that motion is real, The exchange between surface chemicals and deep water could be richer than a static shell would allow. You don't need to decide how thick the ice is tonight. You only need to hold the feeling of water kept liquid from below, salted to conduct, stirred by tides, and sealed against space by a lid strong enough to last and weak enough to fracture. Ocean doesn't have to mean comfort. It just means a solvent with time and energy, and that combination is stubborn. The best kind of possibility lives here. Not loud, not hyped, simply plausible in a way that makes you breathe a little slower. Another step outward, and the brightness dims to a blue-gray, the color of pre-dawn steel. Ganymede fills your frame wider than Mercury would, a reminder that moon can be an understatement. Grooved terrain runs across older, darker plains like wrinkles in stretched dough. Where other moons choose between young and old, Ganymede mixes them on the same face. Lanes of ridges and troughs born from an interior that once pushed and pulled, resting beside battered provinces that have done nothing but keep records. Under the ice, models pile ocean on ocean. Alternating layers of water and high-pressure ice phases stacked like a pastry you would never eat, kept warm by the same long tide that moves its siblings but softened by sheer size and slow radioactive heat from within. Ganymede does something no other moon does. It carries a magnetic field of its own. Not borrowed, not induced, but generated. Likely by a liquid layer in its interior whose motion runs a quiet dynamo. That field makes a miniature magnetosphere nested inside Jupiter's vast one, complete with auroras that flicker and rock as the big field swings around them. From orbit, you can see those auroral oval sway. The amount of sway tells you about the electric properties of the subsurface ocean because the ocean resists the field's attempt to swing the magnetic poles. It's a lovely measurement, the kind that turns light into conductivity and conductivity into a story about layers you'll never touch. Stay in this neighborhood, and you start to feel how everything is connected by fields and tides. The resonance that keeps Io hot keeps Europa stirred and Ganymede shifted. The plasma that Io supplies brightens Jupiter's auroras and alters the radiation where Europa orbits. The giant's magnetosphere reaches into each world's sky and writes moving, invisible script that instruments translate into graphs and, sometimes, sound. The moons are not ornaments. They are parts of a system that exchanges energy like a family trading favors. One more step outward, and you step into age. Callisto sits far enough from Jupiter that the resonance doesn't catch it. The tides are gentler, and the surface wears craters like a coat it never takes off. Chains of impacts, palimpsests of old basins relaxed by slow flow in the ice-rich crust, bright rays faded to gray. Everything about Callisto says time, in a steady voice. It may have an ocean too, hinted by the same trick of an induced magnetic response that told Europa's secret, but if it does, the cover above is thicker and more content to be still. Geology here is less about reshaping than about keeping. Callisto is a shelf of the solar system's library left undusted on purpose. The light across all four rooms is not the same. Io shines with sulfur frost and fresh lava. Europa's albedo is high and clean. Ganymede reflects like weathered ice. Callisto is darker, soothed by age. The radiation, too, is not the same. Jupiter's belts are fiercest near Io and Europa. Ganymede's magnetosphere gives it a bit of local help. Callisto sits in a relatively quiet corner of the field. If you wanted to camp anywhere for a long while, you'd choose the old one. Not because it will entertain you, but because it will leave you alone. Above every scene, the planet's auroras answer the moon's motions. When Io passes, a bright spot marches around the polar oval, tied by an electric leash along a magnetic field line to the volcano world. Europa and Ganymede draw their own fainter marks, footprints in light on a storm-ruled sky, evidence that currents run like wires through space and close their circuits in hydrogen above a planet that hums on short days and long storms. The scale is absurd, the intimacy is not. Here, An eruption can color an aurora. A crustal fault can echo in radio. If you're tempted to put crowns on favorites, grant at least one to each. Io for honesty, a world that cannot hide its heat, forever resurfacing, forever throwing material into space and daring gravity to keep up. Europa for promise, a sealed sea stirred by tides, with fractures that look like questions waiting for verbs. Ganymede for authority, the only moon that runs an engine in its heart, carving auroras into its own sky, while it wears wrinkles and dark plains like generations in a family portrait. Callisto for patience, a place that kept history so faithfully you could use it to calibrate your sense of long. None of this is rushing you. Even the fastest things here, electrons, field lines whipping, a plume lofting into sunlight, feel measured at this scale. You could sit over Europa's terminator and watch a Linnea cast a long, thin shadow across ice so bright it squeaks in your imagination. You could hover near the north of Ganymede and imagine a sky where auroral arcs hang in ultraviolet, beyond sight but not beyond sense. You could watch Io's night side for the red wink of a lava lake and feel your own heartbeat take the hint. You could let Callisto's crater rings pull your gaze outward until you're looking at nothing but the habit of impact, the symmetry of violence slowed by time. Jupiter itself never leaves the frame. Its gravity keeps the beat. Its magnetosphere plays the room. The moon's orbits are not lines drawn on a page, but ropes under constant tension, lengthening and tightening, exchanging energy through resonance the way instruments trade melody in a quartet. The whole system breathes, out in plasma, in with dust, heat moving from tides to rock to space, electricity threading from moon to planet and back. You could call it a mini-solar system and be accurate, but you'd miss the way it feels from inside. Less like a nested set of Russian dolls and more like a tide pool in a storm, bounded by rock, animated by water, full of small, distinct lives sharing one physics. We've kept the tone and the pace on purpose. There's no need to push. You already carry the architecture: squeeze, heat, plume, crack, brine, ice, groove, field, aurora, crater, archive, hush. If you hold those triangles in mind, you can follow any update from any future visitor without getting lost. A new heat spot on Io is a shift in the kneading. A fresh fracture on Europa is a new page in the plumbing. A change in Ganymede's auroral sway is a whisper from the deep. A measurement at Callisto that hints at salter water or thicker ice is a refinement to a recipe that still works. When you look back toward the planet and its belts, you'll see all four lights move with a grace that looks easy and is nothing of the sort. There is elegance in how a resonance pumps heat without breaking orbits, and how a magnetic field can extend a planet's personality across a whole family of worlds, and how a dark ocean can stay dark and alive at the same time, because gravity has decided to pay the heating bill forever. Even the silences are eloquent. The soundless rise of a plume, the unechoing crash of a crater in airless night, the blank stillness of a Callisto morning under stars that don't twinkle. Keep the lanterns in view as you step outward again. The ringed planet is waiting, and with it a weather pattern that draws geometric shapes at a pole, a set of rings that look solid and are anything but, and another pair of ocean worlds. One with lakes under a methane sky, one that sprays water from tiger-striped wounds into the space of its parent. The rhythm will change key, but not tempo. You've learned how to listen, for heat where squeeze repeats, for water where salt conducts, for light where fields close circuits, for history where craters refuse to fade. You cross the dark between giants, and the first thing that reaches you isn't the planet at all, it's geometry. A plane of pale ice tilts into view, a whisper-thin sheet that slices the black so neatly you almost doubt it's real. Then the sheet thickens into bands, and the bands become strands flecked with glints, and only after your eyes learn the lace do you notice the globe tucked inside it. Saturn, swollen slightly at the equator by its quick spin, colored like old parchment washed in gold. From far away, The rings look solid, like a teacher's chalk circle drawn too confidently. Up close, they resolve into billions of icy pieces, from grains as fine as frost to boulders bigger than your living room, all circling together in a dance so polite that collisions settle into order. You skim the ring plane, and the illusion deepens. Across, they stretch for hundreds of thousands of kilometers. In thickness, they manage less than a few stories of a city building in most places. A stack of paper the size of a continent. Flat, delicate, impossibly neat. Sunlight kisses the ice and throws a soft, milky glow that shifts with angle. Where the pieces crowd, the light brightens. Where the gaps open, darkness threads through like ink. And threaded inside the gaps you catch the culprits. Tiny shepherd moons, Pan and Daphnis among them. Each carving and tending its lane, their gravity collecting ring particles into narrow edges and chiseled waves that ripple outward like the wake behind a careful skiff. Those ripples are not decoration. They're the rings remembering the language of orbits. A resonance with a larger moon farther out tugs on a ringlet at the same point every lap, and a repeated nudge piles particles into spiral density waves, tight-wound and precise. Closer in, a small moonlet plows a crisp groove and raises scalloped edges that cast long, needle-thin shadows at low sun. Sometimes faint spokes reach radially across the rings, ghostly streaks that come and go, likely born when sunlight charges tiny grains and electrostatic forces briefly defy the clean circles. If you wanted to teach harmony with ice and gravity, you'd bring a projector and show these patterns in a dark room and let the class fall silent on its own. The rings aren't forever. Saturn's magnetic field catches charged water vapor and dust and herds them down into the planet's upper atmosphere, a steady ring rain that ends in faint, invisible drizzles of oxygen and hydrogen. Over millions of years, that drain thins the bands. They may be young already, tens to a few hundreds of millions of years old, not ancient at all by planetary standards, perhaps born when a moon wandered too close and was pulled apart, when a long-ago collision turned an icy body into confetti. The beauty you're looking at could be a recent event, a bright accident in a long, dim timeline. That's fine. Beauty rarely asks for permission to be temporary. Saturn itself is large in a gentler way than Jupiter, and somehow more theatrical. The day is a little over 10 hours. The fast spin flattens the planet and draws cloud bands that are softer, more blended, as if painted with a wider brush. Storms rise, some routine, some legendary. Every so often a great white spot blooms, a megastorm that wraps the latitude band like a belt and rages until the atmosphere has had its say, then fades and leaves the cloud tops looking like they've been smoothed by a careful hand. At the North Pole, something stranger than a storm holds court. A jet stream shaped into a near-perfect hexagon, 6 straight sides around a central vortex, rotating with the planet like a clock's second hand. Fluid dynamics can build polygons if you push the shear just so. Saturn pushed, the hexagon answered, and then it stayed. Years, decades, an elegant proof that air, given patience and a boundary, can prefer corners. If the rings are architecture, the moons are the neighborhood. One, Titan, owns the weather report. You come in through a haze the color of weak tea and feel the atmosphere thicken around you. Nitrogen mostly, denser than Earth's, cool enough to make you instinctively hunch your shoulders as if a coat would help. Huygens parachuted through this sky once and took pictures that tell the story without adjectives. Branching channels carved into plains, rounded pebbles sitting in dry stream beds, smudged coastlines where something darker and smoother meets something lighter and rougher. The liquids here aren't water. They're methane and ethane, hydrocarbons chilled into rivers and gathered into seas. Kraken Mare sprawling like a lowercase ocean. Ligeia Mare darker and deep. Ontario Lacus like a puddle under a southern cloud. Clouds gather, it rains methane, streams run, the gas evaporates, and the cycle goes around again. It's the water cycle played in another key. proof that nature loves a pattern so much it will replay it with different molecules if that's what the thermostat allows. Walk the shore in your mind, and your boots crunch on something that looks like rock, but is water ice as hard as granite at minus 180 degrees Celsius. Between seas, dunes march for hundreds of kilometers, built not from quartz, but from organic grains. The slow fallout of photochemistry high in the haze, where sunlight and Saturn's magnetosphere pry at nitrogen and methane until they recombine into complex soot that drifts down like a steady, invisible snow. Gravity is a little kind here. You'd feel light on your feet under the thick sky, and a balloon would be less a novelty than a sensible vehicle. Deep down, beneath the ice crust and the hydrocarbons, there's good reason to suspect a water ocean laced with antifreeze. Ammonia, kept liquid by the heat of the interior and the slow squeeze of tides. Titan is a stack, air that could bear the weight of a small ship, weather that draws familiar shapes with unfamiliar stuff, and a hidden sea that makes room for chemistry to linger. Another moon, smaller by far, refuses to be small by personality. Enceladus is bright as clean snow and world enough for a singular trick. Near its south pole, 4 dark fissures, tiger stripes, gash the ice. From them, jets of water vapor and ice grains erupt into space. A curtain of spray falling back as snow across the surface while the finest particles escape to feed Saturn's faint E-ring. At first you might think, frost breath, a superficial sputter. Then you read the particles and find salts that match an ocean in contact with rock, and you taste the gas, through instruments, politely, and find simple organics and hydrogen, a byproduct you'd expect if hot water was reacting with minerals in hydrothermal vents at the seafloor. The conclusion steps forward quietly and stands still until you accept it. Under Enceladus's ice is a global ocean. At its base, hot rock meets cold water. The moon is leaking its interior in a plume you can fly through. And we did. A metal mothership grazed the jets, tasted the vapor, and found the recipe you'd write down if you were building a place where life could, in principle, make an attempt. Water, energy, organics, salts time. That doesn't mean anything is swimming there. It means the chemistry isn't in a hurry, and the pantry is stocked in the right order. The plumes frost the surface so that Enceladus glows like a sugar-dusted confection. They also knit the system together. The E-ring is not a ring in the same sense as the great A and B rings, but its family, a wide, faint halo made and remade by a moon that won't stop exhaling. Everywhere you look, exchange runs the show. Ring particles slam into one another and shatter, stick and settle. A shepherd moon gathers material on its leading edge and leaves a wake. The magnetic field threads charged grains and tugs them into spokes. The rings brighten when open to the sun and dim when the planet's shadow cuts across, then almost disappear when you line them edge-on and the geometry cancels the light. Some outer moons may have been built from ring debris that wandered beyond the planet's tidal grip. Some ring material may be the afterlife of a shattered moon. The system doesn't preach permanence, it demonstrates recycling. Even Saturn's lightness plays a role. Its average density is less than that of water. The joke is that it would float in a bathtub. The reality is that it's a balloon of hydrogen and helium with a dose of heavier stuff at the core, and that makes the gravity gradient across the rings gentle enough for delicacy to survive. The fast spin shapes the field shapes the upper atmosphere, and the upper atmosphere reaches up to sip from the ring's vapor supply through ring rain. On the planet's night side, auroras stand in ovals that breathe with the solar wind and with the ring plasma chemistry, bright enough in ultraviolet to paint the poles in colors you need a special camera to see. You pass under the rings again and let your eyes seek pattern in halftone. Tightly packed ringlets flow into broader bands, the Cassini division cutting a graceful gap between the A and B rings. Not empty, just quieter. The Yankee and Keeler gaps are thin scratches where Pan and Daphnis are busy mowing. At a low sun, shadows stretch long and pick out vertical relief you'd otherwise miss. Wave crests only tens of meters high, casting needle-straight lines that wrap the planet like sheet music. The whole thing is so thin that when the ring plane crosses the sun as seen from Earth every 15 years or so, the rings nearly vanish to a hairline, and the small moons pop out like motes suddenly caught in a beam of light. Saturn's other moons peek from the wings, each a subplot, a walnut-shelled shepherd here, a two-toned relic there. But our thread tonight favors the two with weather and water because they carry a softer kind of vertigo. Titan reminds you that river is a shape before it is a substance, that dunes build wherever the air is strong and the stuff is small and the time is long. Enceladus reminds you that an ocean can hide in plain sight, that a crack can be a window, and that sometimes the easiest way to learn what's inside is to hold out a hand and let the planet breathe on it. Back out beyond the main rings, the E-ring glows faintly, a wide, diaphanous scarf scattered from the south pole of a world the size of County. Inside the main system, ring particles tap and murmur and settle into lanes, their orbits tuned by little moons with names that sound like dessert. High over the north, the hexagon keeps its angles, riding a jet that never quite forgets where to turn. And under all of it, Saturn spins, 10.5 hours per turn, flattened, dignified, busy without noise. You might think such grace would be heavy to hold. It is not. The narrative here is calm because the physics is calm. Gravity chooses circles and ellipses. Collisions choose compromise. The cold chooses ice. And time chooses lace. Where Jupiter's magnetosphere shouts in radio and lightning, Saturn writes notation in ice and lets a moon speak in spray. If you listen in the same quiet way you've been listening all along, the information walks to you instead of making you chase it. You leave the rings in your peripheral vision, and you keep Titan's shore and Enceladus's plume in your pocket. Ahead, the family of giants grows stranger. One world tipped so far over it may as well be rolling. Another with winds that race past the speed of sound, storms that bloom like ink in blue water, and perhaps, deep down, diamonds for hail. The grandeur is about to lean sideways, but the pace won't. You know what to listen for now. Thinness, thickness, tilt, and time. Rings that are fluted by shepherds. Seas that aren't water above oceans that are. Tilt the frame and keep going. The gold of rings fades to a colder palette, blue and blue-green, as if the light itself had chosen to calm down. One world ahead lies so far on its side that its poles take turns pointing at the sun. Another farther out answers with storms that spool like ink in deep water and winds that outrun sound, as if it were a casual jog. Neither offers a surface for your shoes. Both are atmospheres with secrets underneath, and both are colored by methane that edits out red and leaves a calm, oceanic tone in your eye. The first one wears its oddness openly. Uranus turns with a 98-degree lean, a planet that chose to roll rather than spin. So each pole spends roughly 42 years in daylight, and the same in night, while the equator for decades lives at the edge of dawn and dusk. That geometry rewrites seasons into eras. Sunrise can be a generational project. Clouds form in pale stacks, subtle and slow. And then, near equinox, when the sun crosses above the equator, the giant sometimes wakes like a cat that pretends it wasn't napping. Bands sharpen, storms bloom, and lightning cracks through decks of methane and hydrogen where water clouds build far below. It is easy to call Uranus bland until it isn't. The rings are there if you treat them gently with light. Thin, dark hoops, 13 known, drawn close to the planet like strings around a gift. They weren't noticed until a star winked off and on behind them during an occultation, and astronomers realized the planet had drawn a dotted line across the night. Up close, the rings are narrow and sharp-edged, kept in order by shepherd moons whose names sound like they were plucked from a playbill. Cordelia, Ophelia, nudging pebbles of carbon dark ice and rock into obedient lanes. If Saturn's rings are lace, Uranus's are graphite sketches. Economical, clean, almost austere. Magnetism here refuses to sit politely through a lecture. The magnetic field is tilted wildly relative to the spin by dozens of degrees, and its center is offset from the planet's center, as if the dynamo is living in a side room rather than the main hall. That skew makes the magnetosphere tumble and wobble as Uranus rotates, a lopsided umbrella that opens and closes its ribs once every 17 hours. It also means auroras that don't wear tidy circumpolar crowns, but wander, flicker, and recenter with a rhythm that is more quark than clock. Under the methane haze and the hydrogen-helium bulk, the middle becomes exotic. Water, ammonia, and methane don't arrange themselves as familiar liquids so much as hot, high-pressure fluids, ices in planetary shorthand, that conduct heat sluggishly and bend light in a way that makes the interior sound like a lab you visit with goggles. The heat coming out is muted compared with its bigger cousins. Uranus doesn't radiate much extra energy into space. That quiet engine helps explain the planet's reserved weather most years. There is less internal shove to feed the winds from below. A soft, persistent rumor has trailed these worlds for years, that deep inside, carbon may settle into diamond, and that under crushing pressure those diamonds could fall like strange hail. Laboratory experiments suggest hydrocarbons can break down into carbon that crystallizes under the right squeeze and heat. Tiny diamonds, not jewelry. An elegant, severe kind of weather that never reaches a cloud top. It is a theory, not a postcard you can buy, but it fits the mood. Rain you can't see, driven by physics that enjoys a challenge. The moons keep their own decorum. Miranda wears a face that looks like it's been stitched together after an argument with gravity. Blocky provinces, chevrons and cliffs stacked like a geologic patchwork where the crust was torn, tilted, and healed. Ariel and Umbriel, Titania, and Oberon drift in a family portrait named, charmingly, from Shakespeare and Pope, their surfaces telling versions of the same story. Darkened ice, old craters, hints of tectonic stretching. If any of them hide oceans, the evidence sleeps louder some years than others. What matters for your ear, right now, is how the tilt sets the stage. Sun angles that change slowly, seasonal light that paints the poles for decades, a quiet magnet that won't stop shifting its aim. Farther out, the blue deepens. Neptune keeps the same ingredients, hydrogen, helium, methane, but writes a different weather report. Winds whip along the upper atmosphere at more than 2,000 kilometers per hour, faster than the speed of sound in Earth's air, and they carve storms that form black ellipses with pale companions, then fade, then return elsewhere, as if the planet were testing shapes. The great dark spot logged by a passing spacecraft a generation ago eventually vanished. Later, new dark patches appeared, a reminder that permanence is not a requirement for grandeur. Where Uranus plays adagio, Neptune is happy to go allegro. The reason is written in infrared. Neptune leaks heat, about 2 to 3 times more than it takes in from sunlight. Leftover energy from formation still working its way outward, perhaps helped by slow gravitational settling and a brisker convection than its neighbor. That internal warmth feeds buoyant updrafts that build tall clouds of methane ice in bright, high-contrast plumes. Along the mid-latitudes, jet streams rip. At the poles, the patterns organize into polar caps and subtle spirals. Lightning rakes through deeper, water-rich cloud decks, a reminder that even far from the sun, familiar electrical tempers show up when convection gets a vote. The magnetosphere here is also skewed and offset, another dynamo misaligned with its spin, another auroral pattern that requires a patient eye and a little forgiveness when the lights don't sit exactly where textbooks would put them. The field reaches out into a wind that is thin but still persuasive, building a bow shock and a long tail, and coupling to the atmosphere in currents that sing in radio when your instruments tune correctly. Space around Neptune isn't empty. It is a room full of slow music. Discovery stories carry their own lullabies, and Neptune's is the quietest kind of triumph. Astronomers noticed that Uranus didn't move exactly as calculations said it should, an orbital quirk that stuck like a burr in the fabric of the 1840s. And two mathematicians, working separately, ran the numbers and pointed to a patch of sky. "Turn a telescope there," they said, "and you'll find a planet." There it was, a world found first by algebra and then by glass, that turned into disks into bands and weather into a catalog of moons. Before that, it had been seen and mistaken for a star. Sometimes the universe hides in the margins and waits for you to do your homework. Neptune keeps rings too, faint and dusty, with patchy arcs that refuse to spread fully around the planet, held in place by the gravity of a near companion. Seen backlit, they are ghost-thin, a penciled suggestion rather than a declaration. They fit the theme: real, reserved, only available if you ask nicely with the right geometry. One moon here refuses to whisper. Triton moves the wrong way, retrograde, against Neptune's rotation. Proof that it wasn't born in place, but captured, likely from the same distant reservoir of icy bodies that waits beyond. That capture event must have been rough on whatever moon system Neptune had before. Gravity cleans house when it gets a surprise guest. Triton is big, near Pluto in size, and geologically alive in a way that startles if you expected a quiet ice ball. Geysers of nitrogen have been seen spitting plumes into the thin air, driven not by inner fire, but by sunlight warming a dark layer beneath transparent volatile ice, a cold-powered fountain. The surface shows cantaloupe textures and smooth plains, not the cratered sameness of an old object left to drift, and there are hints of a buried ocean thanks to the way Neptune's field induces signals in the moon's interior. The orbit is slowly spiraling inward. Deep time writes a ring in Triton's future. For now, it writes questions. Moons small and irregular litter the outskirts, Proteus, blocky and dark. Nereid on an eccentric path that seems to remember a past rearrangement. Count them, and you end up near 14, depending on the season of discoveries. None clamor for attention. The planet and Triton do enough of that work, the one with winds and the other with rebellion. Stand back from the pair, Uranus and Neptune, and notice what they share while you let the differences keep their flavor. Both are ice giants by composition, their bulk not carved from pure gas like Jupiter and Saturn, but from water, ammonia, and methane ices cooked into supercritical fluids under crushing, camera-shy pressure. Both are wrapped in methane that edits the spectrum into cold blue. Both run dynamos with axes far off their spin poles and centers shifted from the planetary centers, making magnetospheres that look like someone forgot to line them up before turning them on. Both likely host deep layers where carbon chemistry, under pressure, favors crystalline order. Both keep rings so subtle you could mistake them for artifacts in the picture until another picture proves they're real. But they give you different moods. Uranus is composure bordering on aloofness, seasons that take quarters of a human life, whether that speaks in occasional clear sentences rather than essays, a faint ring system drawn like a design brief, a magnetic field that shrugs off alignment as if it had better things to do, and moons that wear scars like stitch flags. Neptune is kinetic, winds that tear along as if eager to arrive, dark storms that appear and retire, heat seeping from inside to keep the pot simmering, a captured moon that orbits backward and breathes cold fountains into a thin sky, and rings that pretend they aren't there until the geometry forces a confession. If your brain wants a single image to keep, take this: a blue world turned sideways, rings like charcoal strokes, a compass needle that refuses to point where you expect, and a calendar so stretched that a single day's weather can fill a month. Then, beyond it, a deeper blue with high white clouds and dark patches, winds so quick you measure them in disbelief, a thin set of rings you mostly feel rather than see, and a large moon moving against the current, with geysers that write temporary commas in sunlight before falling back as frost. You don't need more than that to carry the knowledge forward. Methane takes the red out and leaves the calm colors behind. Tilt turns seasons into epics. Internal heat, or the lack of it, pushes storms or postpones them. Rings can be bold or stingy. Magnetic fields can be tidy or drunk on geometry. Moons can mind their manners or arrive from the cold and reverse the dance. The facts are firm, but they don't ask you to clinch around them. They are as easy to hold as the idea of wind on a winter morning. Ahead, there is a different quiet. Past the last bright planet, a broad ring of small, icy things takes over, the Kuiper Belt, where dwarf planets keep their own councils, where Pluto wears a heart and an atmosphere that comes and goes, where orbits stretch into ellipses that allow neat resonances with big neighbors, and where rumor keeps pointing at a possible ninth, distant, heavy, and shy. The light will grow thinner, the shadows will thicken, and the stories will slow without going cold. Keep the blue in your eyes as you go. It will help you see white in new ways. The light thins and the blue fades until the sun is a bright coin and the space between shadows grows generous. You step past Neptune's long reach into a region that isn't a wall, but a district, the Kuiper Belt, where the solar system keeps its cold archives. It isn't dense the way sci-fi posters promised. It's a wide ring of possibility, sprinkled with small worlds far enough apart that you could drive for years between neighbors and never have to break. Out here, ice is bedrock, darkness is honest, and the news travels slowly, which is perfect for tonight. Start with the one you already know you care about. Pluto is small enough to be humble and strange enough to be unforgettable, a walnut-sized globe in your palm, if Earth were a classroom globe in the corner. It carries a pale heart on its face, Sputnik Planitia, so bright and smooth it looks new, not because it's been scrubbed, but because it's moving. That heart isn't cute, it's geology. Nitrogen ice, with a little carbon monoxide and methane mixed in, pools in a basin and flows like a lazy glacier, creeping around mountains of water ice that stand like dark islands in a frozen sea. The surface there is etched with soft polygonal cells, the convection pattern of ice warmed from below and cooled from above, as if the world were breathing through a blanket. Climb the mountains with your eyes, and you'll find rocks understudy. Water ice here has the strength of stone because of the cold. Cliffs and peaks rise sharp against a black sky where the sun is not bright enough to wash anything out. Down in the flats, the nitrogen carries dunes. Yes, dunes, grains swept into tidy lines by breezes that manage to exist even in air this thin. That air comes and goes with Pluto's long, stretched orbit. Nearer the sun, the surface ices sublimate into a tenuous atmosphere of nitrogen with a seasoning of methane. Farther away, the vapor frosts back down. Seasons here are not cute postcard things. They are migrations of matter from ground to sky and back again. During its last close pass to the sun, Pluto wore a layered blue haze, stacks upon stacks of thin shells that caught the light like cigarette smoke in a projector beam. You don't expect blue this far out. The first time we saw it, it felt like the universe wanted a moment of softness. The company it keeps is a small family with oversized roles. Charon, the biggest moon, isn't a mere accessory. It's so large relative to Pluto that the two whirl around a shared point in space that lies outside Pluto's skin. A binary, not a boss and a tag-along. They're tidally locked to each other, always facing the same way like two dancers with their hands clasped and their eyes never leaving the partners. Charon's face shows a stained belt and cliffs tall enough to make pilots clench their jaws by instinct. Something in its past pulled the crust apart and left feet-high handwriting across hundreds of kilometers. Farther out, tiny moons, Styx, Nix, Kerberos, Hydra, spin like toys wound too tightly. Their chaotic rotation's a reminder that small things can have dramatic moods under big gravity. Pluto's path is an ellipse pushed long, and every textbook line that says sometimes it's closer to the sun than Neptune is telling the truth. Between 1979 and 1999, it was the 8th planet by distance for a while. It never collides with Neptune because they keep a careful rhythm. Pluto belongs to a class of resonant objects called plutinos that complete 2 orbits for every 3 Neptune makes. That pattern keeps the 2 worlds in a safe dance, each past-timed, so that Pluto is never where Neptune might bother it. You don't need the math tonight. You only need the calm fact that gravity knows how to choreograph without notes. If Pluto feels like an exception, it isn't. It's a representative of a crowd that grows every time our telescopes sharpen or our computers get better at teasing faint motion out of noisy frames. Eris, farther and icier, reflects almost all the sunlight that lands on it. Its surface frosted with methane, so bright it would squint you if you could stand next to it. The day is long there. The year is cruelly long, and yet the brightness insists. Haumea spins so fast it isn't round. It's stretched into a quirky ellipsoid and carries a faint ring. Yes, a ring, because its speed and gravity make room for one. Its surface gleams with crystalline water ice, as if something keeps resurfacing it or resharpening grains that should, by rights, go dull. Make wears a warm red tint and likely carries methane ice too. It hints at a seasonal atmosphere that might puff up and sink down as the world moves closer then farther in its slow loop. These are not planets in the old sense. The committee vote years ago settled that word for the 8, but they're unquestionably worlds, round by their own gravity, complex by their own rules, and numerous enough that how many dwarf planets exist is a question with an answer that keeps changing. Between these headliners is the population that taught us humility. The Kuiper Belt holds classical objects with tidy, low-inclination paths, resonant objects like the plutinos that march to Neptune's beat, and scattered objects kicked to wilder paths by ancient shoves. Some are binaries, pairs nearly equal in size, turning around a center between them, a gravity duet that seems to be common out here, where collisions are slow and captures can stick. Others are contact binaries, 2 once separate bodies, now gently glued together. A snowman shape that looks like someone pressed 2 snowballs and walked away. One of those, a little world we first nicknamed for a holiday and then learned to call by its chosen name, showed us a pristine surface of reddish, unbothered ice when a small craft paid a visit. Nothing on it was rushed. The shapes were soft and old. The colors were simple. The story was, left alone long enough, things remember their beginnings. The belt itself is structured by Neptune's gravity like a symphony laid over a hum. There are empty lanes, resonances that clear out certain distances the way a swing pushed at the wrong time dumps the kid. There are crowded lanes, resonances that keep objects in safe beats for billions of years. If you could see orbits as threads, you'd notice braids and gaps, families and loners, a loveliness that hides inside a scatterplot until you squint and the pattern pops. It's tempting to think of the Kuiper Belt as a ring like Saturn's, just farther and darker. It's not. It's more like a rough disk, thickened by tilt, with neighborhood names and quirks, a place where statistics tell truths you can't see in a single glance. You can hold out your hand, palm up, and imagine the cold there. The kind of cold that doesn't sting because it's beyond sensation, the kind that turns gases into rock and rock into glass. Things stick around at these temperatures. Methane, nitrogen, carbon monoxide, all the volatiles that would flee closer in, take their time here. That means surfaces reflect more light when fresh and fade as space weathering. Micrometeorite peppering and solar radiation browns and reddens the top millimeter over eons. It also means that when a world like Pluto swings closer to the sun for a while, a little of that inventory lifts and flows and then returns in a new arrangement. The belt is cold, but it is not static. We can whisper one more rumor while we're here, because this is the neighborhood that started it. A handful of extremely distant objects follow elongated, tilted orbits whose closest approach points cluster more than randomness would suggest. It could be a trick of who we're able to find and where we're looking. Surveys have biases, and biases leave fingerprints that look like patterns. Or it could be gravity telling us there's a large, faraway planet several times Earth's mass, orbiting the sun on a path so long that 1 year would outlast civilizations. The nickname has stuck, Planet 9. Some papers insist the clustering is real. Others say the data are undecided. Telescopes keep hunting around where the math predicts a slow, faint mover might be. The right answer is patience. If it exists, it has no obligation to be easy. If it doesn't, the Kuiper Belt is still beautiful and puzzling enough without it. Either way, the rumor belongs here and nowhere else. Even without a new giant, the residents we've met are plenty. Their variety tells you about the early solar system in a way no museum plaque can. The belt is where small bodies remember their ingredients, organics, ices, rocky dust, without being cooked too hard by sunlight or hammered into oblivion by too many collisions. It's a freezer that never lost power. When comets dip inward along elongated paths, many are visiting from this very pantry, warming and shedding tales that tell us what they carry inside. Some return over and over. Some fall once and are gone. The long-period ones, the true wanderers, likely come from an even farther halo, the Oort cloud, so distant that it stretches toward a light year, more rumor than map at this point. You don't have to go there tonight. It's enough to know that outer is a concept that keeps expanding. The sizes here keep you honest. A big Kuiper Belt object is still small by planetary standards. You can fly around one in an afternoon if you're generous about afternoon. Yet they run their own physics. If they're big enough to be round, their gravity packs them into spheres and their interiors may differentiate. A rock-rich center under an ice mantle. Maybe even a briny ocean in the middle where radioactive decay and the slow squish of tides between a body and its moon keep heat from leaking too fast. A few, like Pluto, may hold on to a liquid layer for billions of years under a thick lid. Water in the dark is a stubborn theme tonight, and it does not apologize. What you don't see is as important as what you do. There are no atmospheres thick enough to lift clouds and hide the ground in most cases. Just frostbite plains and scarred rims under a black that looks almost blue by contrast. There are no nights. Nights are all you get. Only sunlighted hours that are never strong enough to erase shadows. The wide distances mean collisions are rare now. When they happen, they make families, clusters of objects with similar colors and orbits, all chipped from the same parent. One of those families surrounds Haumea, shards that share the same reflective ice and trace the outline of a catastrophe old enough to feel settled. Let your mind hover above Pluto's heart for a beat more. Watch the nitrogen flow fan into fingers where it meets hills of water ice. Follow the line of dunes across a lobe and imagine the gentle winds necessary to sculpt them in air this thin. Lift your gaze and see the haze shells stacked like lines in a notebook all the way up to the edge of space, turning sunlight blue in a world too small to hold on to much for long. Turn to Sharon and spot the cliff that runs for kilometers as if the crust tried to unzip and then changed its mind. Think about two worlds that present the same face to each other forever. It's not romance, it's physics, and somehow that makes it better. Move your eyes outward again and hold Eris as a point so bright you'd think it bragged if it had a voice. Let Haumea spin like a lopsided baton under a ring so faint and so real. Let Makemake keep its red across an orbit that takes longer than any dynasty. All of them drift through a sky so clean they probably don't even feel their own motion. Behind them, the sun is a pin you could cover with a thumbnail held just so, and ahead of them is space that belongs more to the galaxy than to any one star's breath. You don't need to sort or rank. You don't need to memorize catalog numbers. Tonight you keep the feel. Cold that keeps things honest, sunlight too thin to push, orbits that respect Neptune's metronome, surfaces that mix ices the way Earth mixes rocks, atmospheres that arrive and leave on schedules measured in decades, families that remember a breakup, binaries that do not let go. Out here, planet was never the interesting word. World is enough. When you're ready, Keep the image of that pale heart one more moment, because the next miles will talk about orbits and how they bend, about comets and the way their tails always point away from the sun, about myths that try to borrow fear from the sky, and why the sky declines to lend it. You'll carry the Kuiper belt with you as context, a soft rim on the solar system's portrait, a place that teaches you how many kinds of quiet there can be and how many stories eyes can tell when it's given time and a little gravity. You're still holding that pale heart and the slow blue haze in your mind when the next idea slips in almost without asking. Paths. Everything we've met is moving, and none of it chooses perfect circles. Ellipses are the solar system's signature, slightly stretched loops with the sun set a little off-center. So each body has a place of nearest approach and a place of farthest grace, perihelion and aphelion, fast lane and slow lane. The difference can be gentle, as with Earth, where the tilt drives seasons more than distance does. Or the difference can be dramatic, as with Pluto's long oval that trades faint winter for merely dim summer. You don't need to calculate anything. You can feel it. The sky doesn't draw with compasses. It draws with ovals and patience. Those ovals don't keep to themselves. They tug at one another in rhythms that repeat, building resonances that can hold for ages. 2 orbits here for every 3 there, a 5-to-2 echo in another pair, the soft insistence of gravity, saying again but slightly different. You saw it with the moons of Jupiter trading heat through a 4:2:1 beat. You saw it in the Kuiper belt, where whole neighborhoods survive because Neptune keeps time. Even the gaps in the asteroid belt are music, lanes emptied by Jupiter's recurring nudge, as if the metronome clicks louder at certain points and pushes the dancers away. Every so often, a body's path carries it in from the dark pantry and gives us a show, a comet arriving from the Kuiper belt if it keeps a short schedule, or from far deeper storage if it wears a long-period label. Out beyond the belt is a supposedly quiet halo, the Oort cloud, so remote that 1 year of a comet born there can span your species' entire written history, and then some. A passing star, a tidal tug from the Milky Way, a faint nudge at the edge of the sun's magnetic bubble. Any of these can tip one of those icy time capsules onto a lopsided path inward. It doesn't need much encouragement. Gravity will do the rest. A comet announces itself not with a roar, but with a soft glow. As it falls sunward and the light strengthens, the heat is still gentle. There's not much out here, but it's enough to turn ices straight into vapor. The surface of these bodies is dark, darker than you expect, coal and coffee grounds, because sunlight and radiation have worn the grains down into a crust that hides fresh ice below. Tiny jets break through as patches warm and crack, venting gas and fine dust. Around the solid nucleus, an atmosphere blossoms. The coma, a fuzzy halo where sunlight scatters and makes a seeming star go soft. Then the tails appear, and a trick you can trust does the rest. They always point away from the sun. Not because comets are vain and refuse to show their faces, but because 2 pressures, sunlight itself and the solar wind, push the material outward. Dust rides the push of light. That tail curves gently, broad and pale, a brushstroke laid down by grains that lag as the comet rounds the sun, curving like the wake behind a slow boat. The second tail is thinner, straighter, ghostly blue if you could see the color with ease. Ionized gas, carbon monoxide, and other simple molecules, nudged along magnetic field lines carried by the solar wind. The ions don't care where the nucleus travels. They care where the sun's breath tells them to go. The result is a tidy geometry lesson in a night that doesn't otherwise do tidy. On some nights, under some skies, the tails stretch so far they make you feel the scale in your spine. There's no sound to it, no smell, just a directional truth drawn across half a hemisphere. This way is away from the sun. You read it without any math, the way you read waves on a lake and know which way the wind is blowing. The solar system has a lot of these quiet signposts once you learn what counts as handwriting. Even the leftovers become part of your calendar. As a comet returns, it sheds dust, sand and pebbles in a wide, stretched out lane along its orbit. Earth, with its own oval, crosses one of these lanes, and you look up into a meteor shower. Perseids in August say, when we pass through the debris of a comet that loops every 133 years. Leonids in November, source from a more skittish traveler. The dust hits fast, compresses the air ahead of it, heats and glows. Most of it is no bigger than a lentil. It burns away as a green-white scratch across the dark and then is gone. Every once in a while, a larger piece survives that sprint, cold rock turned fire, and then stone again, small enough to land harmlessly in a field or on ice, carrying a chemistry kit from before planets were a thing. Even in falling, a comet leaves you a reminder that this is all one story. The long-period comets from a suspected Oort cloud come once in the life of a town, and then not again for anyone's second chance. The shorter period ones keep appointments we can mark on a deep calendar. Some come back tired, layers shed, surfaces darkened, sputtering instead of singing. A few fade into asteroids. Rocky cores left when the volatiles have bled away. Categories here are less walls and more moods. An object can change its mind with time and lose its tail without losing its place. The tails pointing away from the sun are a good place to talk about myths, because where there's a dramatic sky, people will hang a story. For as long as there have been arguments around fires, alignments and apparitions have been promoted to omens. Planets do line up sometimes, if by line up you mean fit within a wedge of sky. Sometimes, seen from Earth, they cluster prettily in one quadrant. Sometimes they march behind the sun like a neat parade. The gravitational net result of that choreography on Earth is vanishingly small. The moon lifts oceans twice a day. The sun raises a tide, you can measure if you're patient. Jupiter and Saturn together, during a photogenic conjunction, raise, well, an effect that would lose a fight with the gravity from a truck parked on your street. Beautiful? Yes. Mathematically interesting? Always. Dangerous? No. The sky is not a newspaper horoscope waiting to surprise you with a personality test. It's geometry viewed from a moving platform. When alignments produce earthquakes in fiction, that's because fiction hates quiet correctness and loves a convenient villain. The real villains for tectonics are inside Earth: heat, buoyant rock, subducting slabs, ancient engines that need no help from a distant planet to do what they already do. Another myth prefers to worry about air. Won't it all leak away? Asks the part of your brain that remembers balloons gone sat a day after the party. The answer is gentle and honest. Atmospheres do leak, but slowly and not all the same. On any world, the lightest gases, hydrogen, helium, can sometimes outrun gravity at the top of the atmosphere, atoms at the far right of a velocity curve slipping the grasp of the planet like clever guests ghosting a party. That's thermal escape. There are other Messier ways to lose air: sputtering, when the solar wind smacks the upper layers and kicks atoms free; sweeping, when magnetic fields drag charged particles along and out; chemistry that steals oxygen and tucks it into rocks. Mars, with its small size and missing global magnetic field, felt these leaks more acutely. Venus, without a protective magnet, but with an atmosphere so thick it barely notices, loses some light gases while holding on to carbon dioxide like a champion. Earth leaks hydrogen, thousands of tons a year, while the magnetic field deflects most of the solar wind's rude behavior and keeps the rest manageable. Instead of drama, you get budget, inputs and outputs, long cycles that store gases and stones and then bring them back out through volcanoes and the weather's slow accounting. Look at it that way, and the air becomes a bank ledger you can trust across eras, not a bucket with a hole you can't fix. The idea of escape carries a smaller, almost tender counterpoint: capture. We've seen rocks become moons, and moons become rings, and the trade can go both ways. Inside a planet's Roche limit, the distance at which tides pull harder than gravity can hold, solid bodies that venture too close can be torn into streams of rubble. Those streams can settle into rings, as we suspect happened at Saturn. And those rings, over time, can clump at the edges and, beyond the limit, build small moons from their own leftovers. It's a birth story written in reverse of the breakage story. You saw the aftermath in Saturn's graceful bands, shepherded by moonlets like Pan and Daphnis. You saw the continuing exchange when Enceladus's plumes fed the faint E-ring. Rings are temporary on cosmic time. That doesn't make them trivial. It makes them alive in the only way ice and gravity know, by changing. If ellipses are the favorite shapes, retrogrades are the favorite exceptions. Triton orbits backward. Some small moons of the giants do, too, captured fragments that came in sideways and kept their rules. Comet paths defy easy generalization. The short-period ones arrive clipped and tidy. The long-period ones whip in from directions that feel random, because random is what they partly are. The commonality isn't neatness, it's obedience. Every path is a solution to the same gravity problem with different starting conditions. You can lull yourself by that thought. The universe is many things, but usually, despite our fondness for drama, it is consistent. When people ask whether comets can kill worlds, they're asking a fair question. Large bodies have struck Earth. One of those strikes rearranged biology in a way that left feathers where teeth once were and gave mammals the opening to get noisy. But scale matters, and frequency matters more. Tiny meteoroids kiss the atmosphere and burn away nightly. Chunky rocks light the sky with a flare once in a very long while, and then fall in fragments you can hold, black and heavy, smelling faintly of spent matches. Big ones are rare. We map many of the near-Earth asteroids that could be a problem. We practice nudging small ones so the math becomes muscle memory. The solar system is not out to get you. It's just running its logistics. Back to the comets and their tails, because there's a detail you can pocket that makes every photograph smarter. The dust tail curves with the orbit. The ion tail points almost straight away from the sun. If you see a comet after it rounds perihelion, it can sometimes look like it has two tails pointing in opposite directions. One away from the sun, ions, and the other trailing behind along the path, dust. You can read the orbital direction from that split like you read the direction of a slow river by watching leaves. You just learn to tell time by watching light on airless rock. Learning to tell direction by watching tails is the same kind of satisfying. There's another quiet truth. Sometimes comets were sodium tails you can't see without the right filters, glowing in a narrow color you don't notice. Sometimes the nucleus sheds chunks and the comet builds multiple dust tails, delicate fans like peacock feathers done in ash. Sometimes a comet fractures and becomes a small family, pieces drifting apart along the same track, a string of beads you can resolve with binoculars under a good sky. None of this is required. All of it is allowed. The solar system isn't a strict classroom. It's more like a studio where physics gives you the available tools and then watches what happens. As you drift through these ideas, you can feel the earlier scenes lining up like faint landmarks through fog. Mercury's off-center magnetosphere, making room for the wind to write directly on rock. Venus's thick air catching sunlight and refusing to let it go. Earth's field and plates cooperating to keep a climate in the middle lane. Mars leaking atmosphere molecule by molecule while it sketches canyons that would swallow countries. Rubble piles that move when sunlight thinks too hard about them. Jupiter's stripes and motes. Its auroras painted in part by a volcanic moon. Saturn's rings raining into the planet while a smaller world sprays a saltwater signature into space. Uranus's sideways year and Neptune's supersonic winds. Pluto's ice convection and the edges of an atmosphere that comes and goes. Comets and orbits just gather the threads into a single, gentle braid. Everything responds to the same light and the same pull. The difference is written by distance, mass, composition, and history. If there's a mantra in this section, it's almost embarrassingly simple. The heavens are lawful and largely indifferent, and that's good news. Ellipses explain the motion. Tails explain the direction. Myths explain us more than they explain the sky. Alignments are pretty. Escapes are slow. Rings are temporary and generous. Comets are cold messengers that write with light and dust, then retreat to darkness without asking for applause. You can sleep on a planet that lives under those rules. And if you want a final picture to slide under your pillow tonight, a comet arcing in on a path set long before you were born, halo swelling, a thin blue spear of ionized gas pointing away from the sun, a softer fan of dust curving along the track, Earth crossing a lane of its shed grains months later and making a meteor shower for someone wrapped in a blanket on a hillside. Far above, planets that look close from the ground are in reality far apart and barely aware of each other's company. Their combined tug on your bathtub less than the moon's daily whisper. Around one of those planets, rings so thin they can vanish edge on are slowly sifting into the air, while just beyond, a moon with oceans in the dark paints a faint ring with its breath. Nothing in that paragraph is urgent. Everything in it is true enough to keep your pulse low. You're ready to keep drifting. The next stretch will widen the frame again, from mechanics to eras, from the solar system's age and long orbit around the galaxy to the tools we built to watch the whole show, from the telescope that keeps an eye on nearby weather to the little emissaries already past the sun's protective bubble, carrying the sound of waves and greetings into a space that doesn't do echoes. You've been following ellipses and reading the sky's quiet handwriting. Now turn your face toward the one author behind most of those sentences. The sun sits there like a simple idea, round, bright, reliable, and of course it's none of those things. It is a living engine. It is a slow drum. It is quite literally the clock on the wall of your days. Begin where the light is made. Down in the core, where pressures are so high rocks would beg for mercy if there were rocks to beg. Hydrogen is squeezed until it forgets it ever wanted to be anything but helium. That fusion is choreography at 15 million degrees and beyond, particles bumping and stitching themselves together, releasing energy each time they settle into a tighter embrace. If you could listen to mass whisper as it vanished into light, you'd hear the sun convert more than 4 million tons of itself every second into energy that pours outward. Tons per second sounds violent. The reality is steady. The middle of a star burning with patient joy. From the core outward, the mood changes. Above the fusion furnace is the radiative zone, where newborn photons don't so much travel as wander. They scatter, reabsorb, re-emit, a terrible commute that takes hundreds of thousands of years to cover a distance your mind would rather measure in minutes. At last they reach the convective zone, where hot plasma rises, cools, and sinks like water just before it boils. Look at the photosphere through a telescope, and you can see that last layer's signature as granulation, a field of bright cells rimmed by darker edges. Each one a bubbling plume tens of thousands of kilometers across that lives for minutes and then dissolves into another. Calm is surface appearance only. The surface, by the way, is a fiction we keep because our eyes like boundaries. The photosphere is just where the gas becomes transparent enough to let light out. Its temperature sits around 5,500 degrees Celsius, which is gracious by stellar standards. Above it, the atmosphere thins into the chromosphere, and then something indecorous happens. The temperature shoots up. The corona, the outer atmosphere you see during a total eclipse as a pale, feathery crown, sizzles at more than 1,000,000 degrees. Hotter than the surface beneath. The sun breaks your intuition without breaking stride. How? The running theories are elegant. Waves launched by magnetic fields dumping energy as heat, countless tiny magnetic reconnection events, nanoflares, popping like invisible bubble wrap. The truth is likely some blend. What matters for your inner ear is that heat can travel up the way sound does through a violin string, and the air above a star can be much more than a simple afterthought. The sun vibrates, too. Not just the familiar 5-minute puffs you'd hear if you could translate light into audio, but whole sphere oscillations, pressure waves ringing through the interior the way notes shiver through a bell. Helioseismology, scientists reading those waves. Let's us map the inside of the sun the way geologists map Earth's interior with earthquakes. From those ripples, we learn how the rotation changes with depth and latitude, how flows twist beneath the skin, how the dynamo stirs in the deep. It's a beautiful habit of nature. If a thing can sing, it will, and you can learn it by listening. All that motion makes and unmakes magnetism. The sun doesn't have a simple bar magnet inside. It has a churning conductor. Differential rotation. Faster at the equator, slower at the poles. Stretches and tangles magnetic field lines until they buoy out of the surface, punch through, and make spots where the field is strong and heat flow is suppressed. Sunspots look dark because they're cooler than their surroundings, not because they're cold. They arrive in pairs and clusters, march toward the equator as a cycle matures, and then fade as the cycle resets. About every 11 years, activity climbs to a maximum and then relaxes toward a minimum. Every 11, the global magnetic field flips, north and south trading places with the confidence of a magician who's been practicing for a few billion years. Track it long enough, and you see not just an 11-year rhythm, but a 22-year magnetic heartbeat. Polarity, flip, regular enough to set your expectations by. When the field tangles, it can snap. That's a flare, sudden release of magnetic energy into light across the spectrum, from radio to X-ray. Sometimes the snap throws off a coronal mass ejection, a billow of plasma and field that swells into space and goes looking for arguments. Most of those clouds miss us. Space is large, and luck is a quiet statistician. When one does arrive, Earth's magnetosphere reads the knock at the door and answers with currents that circle the planet, auroras that surge equatorward, and a brief reshuffling of space weather that human technology can feel. You've heard the symptoms. Radio fades on the sunlit side. GPS gets a little drunk. Power grids grumble while operators reroute load like careful chess players. Satellites take a pinch of charge and bleed it off before it nips a circuit. Storm is fair. Apocalypse is not. And the reward for a mild storm is a sky painted in curtains of green and violet, oxygen and nitrogen singing at the top of the world. Push farther out, and the breath of the sun becomes something you can treat as wind. We wrote it earlier. Remember the Parker spiral, the magnetic corkscrew wound into space as the sun spins? That wind picks up at the corona's open field lines, flows outward at hundreds of kilometers per second, and fills a bubble, the heliosphere, that encloses every planet and most of the comets you've ever wished on from backyard. The bubble isn't rigid. During active years, it swells. During quiet years, it relaxes. Where the supersonic flow finally slows below the local sound speed, there's a termination shock. Beyond that is the heliosheath, a turbulent borderland. At the heliopause, the pressure from the wind and the pressure from the interstellar medium balance, and the sun's influence gives way to the larger sea between stars. Two small emissaries told us what it's like out there. Voyager 1 crossed that last border in 2012 and Voyager 2 in 2018, and each reported the same basic message when they stepped outside. The magnetic field no longer points the sun's way. The charged particle mix is different. The background of cosmic rays is louder. Their signals take more than 20 hours to reach you. Whispers from a place where the sun is another bright coin among many. They're still talking. It's one of the gentler miracles of the 20th century that something the size of a hot tub, built with the math and patience of an earlier decade, is now sending weather reports from the suburbs of the sun's reach. Closer in, a very different craft decided to be brave the other way. A thick carbon composite shield up front. Instruments huddled in the shade. The Parker Solar Probe began to dip into the sun's corona itself. It flies faster than any object we've ever built, loops closer with each orbit, and samples the birthplace of the wind, measuring kinks in the magnetic field, chasing switchbacks, tasting dust, counting particles before they've had time to forget the physics of where they came from. It is an intimacy you rarely get with a star, data taken not from afar, but from the actual glow. The sun's influence is not just local. It holds more than 99.8% of all the mass in the solar system. Its gravity is the thread. The planets are the beads. Every grain in the asteroid belt, every ice lump in the Kuiper belt, every piece of debris that ever traced a meteor over your house returns to the simple curve of its pull. And while the planets go around the sun itself goes around the galaxy, taking the entire bubble with it on a 225 to 250-million-year loop. We are moving through the local interstellar cloud, a faint concentration of gas and dust inside a larger cavity. The local bubble, likely carved by ancient supernovae. You are, without exertion, sailing through a galactic fog with a magnetized cocoon for a hull. Light, once it finally escapes the crowd inside, does the last leg easily. From photosphere to Earth is about 8 minutes and change. Time enough to pour a glass of water. Time enough to remember that what warms your face left the surface of a star when you were still deciding whether the afternoon needed tea. If the sun went dark right now, don't worry, it won't. The sky would stay normal for those minutes, and the gravity would too. The past is the present when you look up. You've met sunspots in passing. Hold one in your mind a little longer. A big spot could swallow Earth. It is darker only by contrast, still thousands of degrees, with a magnetic field so strong it pins gas in place and damps the flow of heat from below. Around a spot, bright plages and faculae pop up, and the limb of the sun, its edge, can look a touch brighter because those features show up more easily against the dark of space. During active years, the number and size of spots climb. During quiet ones, the disk goes nearly unblemished. Old sketches from small telescopes and new images from cameras, so sharp they show the granules lining up like fish scales, tell the same story. Pattern, patience, polarity, flip. If you step back far enough, the entire enterprise has a biography. Hydrogen burning quietly, helium piling up in the core. Billions of years from now, that helium ash will build until the core can't sustain the same pressure-temperature balance. And the star will answer by swelling into a red giant, its outer layers expanding, its light shifting, its breath stirring comets into new orbits. The inner planets will not enjoy this. There's no reason to make it poetic. Later, the star will shed its outer layers into a glowing shell, the misnamed planetary nebula, and the core left behind will cool as a white dwarf, an Earth-sized ember that glows without fusion, slowly dimming over trillions of years. None of this asks for the present tense. For you, the sun is steady and middle-aged with the confidence of an honest job. The steadiness has texture, though. Solar cycles modulate the wind, which modulates the heliosphere, which modulates how many cosmic rays reach Earth's air. During solar maximum, the shield is stiffer, fewer of those high-energy outsiders make it in. During minimum, more arrive. The effect is modest on the ground, but real higher up and in the electronics we trust. This is one of those places where space weather stops being a metaphor and becomes a planning assumption. Astronauts time spacewalks, operators schedule satellite maneuvers. Pilots adjust long polar flights where communications rely on the upper air behaving itself. The sun is a star, yes, but it's also a neighbor with moods. Hold in one palm the small facts. 4 million tons per second, 5,500 degrees Celsius at the photosphere, /1,000,000 degrees C in the corona, 8 minutes to your skin, 11-year flips, spots that can erase continents in a silhouette, and in the other, the large feelings, hum, heartbeat, breath, crown. They fit together better than you expect. The numbers don't make the poetry smaller. They give it bones. And once you feel that bone structure, you can recognize its shadows everywhere else. On Jupiter's auroras, brightened by a moon that won't stop erupting. On Saturn's rings, eroded by a rain fed by the planet's own field. In Uranus's drunken magnet, Neptune's blue winds. In Pluto's haze, layered like lines in a score. The sun wrote those measures. Space plays them back. You might be tempted, standing at a window on a winter morning, to call the sun a simple heat lamp. That's fine. Let the comfort be small when you need it. But now you also know the longer story. And if you want to carry any single image from it into your sleep, make it this. The star is not a static furnace, but a humming, vibrating, flipping, shedding creature of fluid and field, musical and mechanical, busy and benevolent, a thing that holds nearly all the mass, sets nearly all the time, and still allows small worlds to be themselves under its light. The road ahead widens one last time. There's the edge of the sun's breath we spoke of before, the invisible boundary where its wind yields to the galaxy's pressure. There are the little gold emissaries already beyond it, carrying songs and greetings. There's the slow outward creep of our moon, lengthening days by a whisper each century, and there are tides and fields and memories written in stone and ice. You've learned the pulse. You can follow the rest without effort. Keep the sun's steady hum in your chest, and let's gather the last, quieter notes. The ones that don't shout, the ones that feel like the soft little clicks of a clock you only hear when the house is still. Think of this as a slow walk back toward your pillow, pausing for details that make the whole sky easier to live inside. Start with the tiny scorched world that opened our path inward and then ducked behind bigger stories. Mercury is not bare so much as translucent. It doesn't bother with a true atmosphere. It wears an exosphere, a near vacuum where atoms pop loose from the surface and drift without bumping into one another, like confetti caught in a room with no walls. Sodium and potassium glow faintly in sunlight. Oxygen whispers in the mix. The supply is constant because the source is constant. The solar wind taps at the ground. Micrometeoroids tick by, and atoms hop free. It's a ghostly thing, and it suits the planet, present but never a curtain. If you flew to Mercury's poles and looked down into craters that never see the sun, you'd find something that doesn't fit the rest of the world at all: ice. Water arrived as it always does in airless places, carried by comets, delivered by asteroids, released by rock, and where the light never reaches, the cold winds. In perpetual shadow, frost becomes bedrock, tucked behind rimmed walls that hold night forever. The closest planet to the sun keeps pockets of winter locked like secrets. That's Mercury's kind of joke. Its insides tell a sharper one. The core is huge, disproportionately large compared with the planet's size, as if some ancient event stripped away a thick mantle and left a world built around its own heart. Even so, the core still moves enough to run a small dynamo and raise a modest magnetic field. Not the compact umbrella Earth wears, but not nothing either. The orbit, always slightly eccentric, carried an extra little precession that made Newton squint. General relativity stepped forward, curved space-time by the right amount near the sun's mass, and the numbers fell into place. A tiny, steady shift in the point of Mercury's closest approach, perihelion, became one of Einstein's first clean wins. A scorched, air-poor pebble helped confirm the geometry of the universe. I like that about Mercury. Proof that small and quiet can still be decisive. If you step back to our own satellite, so over-photographed we forget how weird it is, you get another pocket-sized truth. The moon is unusually large for a rocky planet, and it acts like it. It steadies our tilt, tugs our tides, and shows up in daytime like it doesn't know it's supposed to be dramatic only at night. Its surface barely changes. With no wind, no rain, no recycling of crust, the prints and rover tracks will sit for ages unless a meteorite decides to do housekeeping. And yet, inside there's motion. Moonquakes rattle, some shallow and sharp, some deep and slow. Thermal stresses crack and settle. Tidal tugs flex the crust. A world can look frozen and still have nerves that twitch. Between Mercury's shy exosphere and the moon's long memory, you can tuck one more comforting thing. Our tools have been watching patiently. A telescope barely above our air, the Hubble, has spent decades taking portraits of our neighbors the way a favorite aunt does, regularly, fondly, with a good eye for change. Storms on Neptune, there then gone. Dust veils on Mars, swollen, then thinning. Bands on Jupiter, brightening, braiding, breaking from low Earth orbit. Hubble has caught the outer planets in acts of weather, building a time-lapse of seasons and tempers that our quick visits by flyby could never have given us. It's not just for galaxies in deep time. Sometimes the best overview is literally an overview. If you prefer numbers with your evening tea, there are two you can set like bookends on the shelf. One is the solar system's age. About 4.6 billion years since a cloud of gas and dust fell in on itself and lit a star at the middle. Grains stuck, pebbles clumped, planetesimals collided, and the whole place went from gravel pit to orchestra in an unruly rush. The other is the sun's year. Roughly 225 million Earth years to make one lap around the galaxy. We are not parked. We are cruising, the entire heliosphere sliding through the local interstellar cloud inside an even larger bubble blown long ago by supernovae. Everything you've heard tonight, the dust tails and ring rain, the blue haze over Pluto and the hexagon in Saturn's north, rides along inside that slow galactic turn. While we're on the subject of riding, there's a detail in your back pocket already, but worth saying aloud once more. Leaving the solar system takes decades at our best sprint. Voyager 1 and Voyager 2 left in the late 1970s, toured the giants with gravity's help like smart hitchhikers, and only crossed the heliopause, the place where the sun's wind yields to interstellar space, after more than 40 years. They're still whispering to us through the deep space network, faint and stubborn. They carry a gold record on each side, a lacquer time capsule with birdsong and waves and greetings, Bach and Blind Willie Johnson, a mother and child. If another intelligence never finds them, that's fine. The gesture was as much for us as for anyone else, a quiet proof that we thought about how to say hello. You can drape the rest of the little truths like strings of lights across what you already know. Most of the solar system's mass sits in the sun. Nearly all the rest hides in Jupiter and its siblings. That leaves a sliver for all the rock and water and metal you stand on. Planetary rings are temporary and generous, likely young around Saturn and raining into the planet even now. Atmospheres leak slowly. Hydrogen sneaks off first, while magnetic fields and gravity do the practical work of holding on. Some moons are children of impacts, ours probably. Others are captured, hello, Triton. Others condensed in place around their giants. Some keep oceans in the dark, Europa, Enceladus, maybe Callisto, and Ganymede. And some spray samples into space so that you don't even have to land to learn what's inside. Comet tails point away from the sun because light and the solar wind are pushy. Meteor showers happen because old comets shed crumbs and we drive through them. Planetary alignments are stunning and about as dangerous as a stack of oranges. The myths tell you about us. The sky tells you about physics. What's left is tone. The solar system doesn't feel like a machine once you learn the parts. It feels like a tide pool, contained but alive, rule-bound but expressive. Heat squeezes here and makes volcanoes on a moon. Tides flex there and make an ocean under a shell. A magnetic field here grows a cathedral that reaches past other worlds. A ring over there is so thin you could walk through it and not notice, and yet so wide you'd feel small for a week. It's all one score written in variations. Once you recognize the theme, every new verse is familiar without being boring. And home? Home is a plate that moves, a core that runs a dynamo, a field that turns aside storms from the sun, an ocean that holds heat and gives it back at night, a tilt that makes the year a story instead of a calendar, and a moon that never changed its mind about us. You can sleep on a planet like that with the window cracked for the hum of the fan and the promise that, come morning, gravity will still be pointed down and the sky will still be blue for reasons that make sense. Those last emissaries, the Voyagers, are beyond the sun's breath now, crossing into the galaxy proper with our return address etched into copper and gold. The little hummingbird that dips into the corona, Parker, keeps skimming the fire, counting particles, and stitching together the last missing notes in the sun's song. Hubble keeps its long watch. Other eyes take their turns. That's the other secret here. We're not just passengers. We're also the witness species. and we've gotten very good at quiet. You can set the entire tour on a single shelf in your head now. Mercury's ghost air and polar ice. Venus's slow, backward day and furnace sky. Earth's moving stone and faithful field. Mars's canyon the size of a continent and a volcano that outgrew good manners. The belt's rubble piles and salt-bright dwarf planet. Jupiter's stripes, its great storm, its private radiation weather and a family of worlds. Saturn's lace and its plumes and its lakes under a methane sky. Uranus tipped like a rolling barrel. Neptune's winds that outrun sound. Pluto with a heart that flows. The Kuiper belt's quiet and its rumors. Comets riding arrows away from the sun. The sun itself humming, flipping, and breathing a wind that carves a bubble in the galaxy. All of it steady enough to fall asleep to. All of it alive enough to dream about. Slow the scene down until the edges soften. Let the bright coins of the planets dim to warm embers. The rings lose their glitter. The blue of Neptune fade into the color of deep water at night. Picture the sun not as a disk, but as a warm, steady hearth at an infinite distance, a hush you can feel more than see. Imagine the Voyagers as faint lights moving through that hush. One ahead, one just behind, each carrying a thin thread of sound, a greeting, a heartbeat, a little music that curls out and then vanishes into the dark like breath on a cold morning. Bring the camera closer until you can feel the quiet of our own air. The fan you turned on at the start is a small analog of the solar wind, and it is constant, and it is kind. Under your ribs, your own tide rises and falls. You could map your inhale to Jupiter's 10-hour spin, your exhale to Saturn's. You could match your pulse to the slow, soft drift of a methane cloud above Titan's sea, or to the whispered fall of ring rain on Saturn's upper air. Let those paces set the length of your thoughts. What needs remembering will wait until morning. The canyon will still be deep. The ocean beneath the ice will still be dark and patient. The diamond rain, if it exists, will still be falling in a place you will never need to go. Hubble will still be watching. The sun will still be humming. The moon will still be tugging at the world's edges, and your window will still, sweetly, face east. Let all slide a little farther away. Let the distances lengthen until even worry takes too long to travel. Tonight you have traveled far enough. The universe can wait. Close your eyes, and sleep comes in on a quiet orbit, always returning, always gentle.